Hello, everyone. Good evening. Okay, I did not forget about the class. Yes, as there, I was just waiting for everyone to join in. Okay. So yeah, we have arranged two extra classes, right, for this week. So we have one extra class that's tomorrow and one more on Sunday. The class timings for tomorrow's and day after tomorrow's class are 11 to 2 p.m. So I prefer doing the classes in the weekends in the morning, so that you also get free for the entire day. And right, if you have plans to go out, you can still go out in the evening and all. So tomorrow and day after tomorrow, we have classes from 11 to 2 in the morning. Okay, that's one announcement. Apart from this, yeah. Okay, so we are not like a little bit behind, but we don't have any contest this week, so we can use that time for both this. So both days will be going for revision. So ideally, we have a contest on Saturday, but since this week you had two holidays and we cannot have a contest because we have not covered that much ground so far. So this week there is no contest. There is actually revision classes itself. Okay. Sunday also revision, not revision. So there is these classes are not exactly revision classes. These classes are exactly the course that will flow. So we'll try to complete loops and nested loops by tomorrow. Day after tomorrow, I think we'll be starting with arrays. Okay. Tomorrow evening is soft skill. Soft skill is completely different, right? So that all those sessions they'll have intermittently. So for example, soft skill, resume building, all those things that will go on parallelly, and that is you would have separate slots for that. Okay, so I guess tomorrow's evening class where you don't have contest, that session would be utilized for your soft skill training. Okay, that's it. Any doubts, anything regarding timings or anything? So generally it would be on Saturday, Sunday, it would be on from 11 to 2, right? So that's the timing that we are going to follow. Okay. Okay, so let's quickly start then if you don't have any doubts. Okay, so let's first visit the assignment part today since I've not touched this part. So okay. Any doubts anywhere in the assignment questions? Anything that you're stuck? Any doubts? Rotation one. Okay. So rotation, I guess, is a loop question, right? So we have not done that one till now, that part till now. Okay, number rotation, factorial, number of days, palindrome. Okay. So I guess regarding the conditionals one, do you have any doubt? Any doubts on the conditional questions? And I gave you even few questions to solve yesterday. Okay, so let's visit that. Let me quickly recap of what we did yesterday. Okay, so okay, let me just go through what we covered yesterday. So we understood how to take inputs, right? So from there we started. We tried to understand. Okay, we took inputs. Now what's next? So once we have taken input, then we have we can write code that will run line by line, right? But now since we always want to write code that does not run every time, it runs until if a certain condition is satisfied, we want to run the code. If the condition is not satisfied, we don't want to run the code, right? Simple. So for that, we have conditionals. Now conditions can be written in multiple ways. For example, we have if conditionals, we have we have if conditionals, we have switch case, we have ternary operators. So we have different kind of conditional logics that we can write. All of them are basically doing the same thing. If the condition is satisfied, we do some particular work, we do some assignment, or we run a particular logic. If the condition is not satisfied, we don't run that logic, right? As simple as that. Now, in order to write these conditionals, we have different operators. For example, we have relational operators. These operators are used to find relations between two variables or values. We have logical operators, which are used to club multiple relational conditions together. Okay. Now, for example, we have AND logical operator. So what does this do? This takes into relational operation and it finds out the AND operation of that. So what is AND? So if both the conditions are true, then the final result of this AND operation is true. And if any one of them is false, then the final result is false. So OR is exactly reverse. If any one of them is true, then the final result is true. If both of them are false, then only the final result is false. Okay. Not is simply with something which converts the true to false or false to true. Okay. Now we understood about how we can write conditional. So there are multiple ways. We can write a single if, we can write a if else, or we can write a if else ladder altogether. Okay. Okay. Now we saw different yes, I'll explain the ASCII part right now. I don't think you need it. I'll cover that part today. Okay, we'll have some time to cover that. Don't worry. Okay, so next we have like if else, where we write multiple conditions. Now whichever condition is true, only that particular code runs, right? If there are multiple conditions true, then the condition which comes true first, that particular code only runs, and the remaining block, even though they are true, that will not run. So for example, for input 5, this condition also true, this is also true, this is also true. So it will run the first one and it won't run anything else in the ladder. Okay, so that's how if else conditional logic works. Okay. Now after that, we saw like how we can write multiple complicated conditions using logical and or operators. Now, okay. Now we saw how we can write multiple relational operators using logical and or operators, and we can have multiple statements that is running based on this particular expression. Okay. After that, we saw how we can write even very complicated expressions using this relational logical or operator combinations, and we can how we can figure out the solution to any particular complicated expression that is written using relational logical operator. So the top priority is brackets, but if you don't have brackets, then the first thing that gets executed, the order of execution is order of execution. So this is firstly not, then the and then finally or. Okay. So this is the order in which the expression gets executed. So firstly, all the nots will get executed. They have the highest preference. Then we run the ands, right, which is like whichever and operations are there, that will get run first, right? So here example, this and operation will complete first, and then this and operation, and then finally we do the or operation that we whatever ors are limited, right? If you have multiple of them, then we run them from left to right order. Okay, that's it. Then we have nested if. So this logical operator and relational operator combination is very complicated, and sometimes it becomes very difficult to write logic using combining them. So we also prefer sometimes writing complicated expressions using nested if, where we break down this condition into multiple smaller conditions and smaller if else. So if a particular condition is true, then if we decide whether we want to run whatever is the logic we want to run, if this condition itself is false, then what is the logic that we want to do. So for example, let's say if we want to check if A is in a range that is 10 to 20, how would we do is we'll check if A is greater than equals to 10 and less than equals to 20, then we say, okay, it is in range of 10 to 20. Here we simply check if A is greater than 10, that means it can be in the range. It's not sure that it is, but it can be. Now, if it is not greater than 10, it is lesser than 10, it's negative number, it's 5 or something, then it is definitely not. In that case, we just put not in range. Okay. Now, if it is greater than 10, then we check whether it is less than 20. If yes, then it is in the range. But if it is not less than 20, then it is definitely not in the range. Okay, that's it. We have leap year. Then we understood, okay, what's a leap year definition is, and I gave you an assignment of how to write the leap year logic in both the ways. Did any one of you try? Done? Yes. So let me quickly give you the solution. Notes so the community has a channel known as lecture notes. You can find the notes there. I guess yesterday it was not opening, so I did not paste it. So I shared it in the chat. I'll today try to connect the community, right? So yeah, we'll check if it is working now. Okay, let me quickly complete this. So what's the definition of leap year that I gave you? So the leap year definition is it is divisible. Today also it's not opening. I'll get it checked with the tech team. Ideally, it should not happen in this way. It was working as fine. Okay, so I'll reach out to the tech team why it's not working. Okay, meanwhile, right, you can use this chat. I can share it. You can share it in the groups. If you have WhatsApp groups, you can share it there so that at least it reaches to all the students. Okay, it's working. Yesterday it was not working for me. Few students it was working, so I'll check that. Okay. Awesome. So whatever notes I would be like, whatever I would be doing in the class, so that I would be writing it here, right? So I generally write it in the order that we follow in the class. Apart from this, any other notes that's already there in portal. And if you need any formal notes on this basic topics, because there is no theoretical question that you get from these basic topics. Okay, being honest, there is no theory that someone is going to ask what is while loop, what is for loop, or what is tangling, and no one asked this theory, right? They would just need you to understand this, and you probably will most likely get input output questions from here. That, for example, dangling else case or fall through. So all this will just a simple input output question, and that's what I'm trying to show you by examples over here. Okay. Oops concept theory is there in module 2, and for all those things, right, where you will get theoretical questions in interview, for that we have already put notes in the portal, right? And that is already there, and if required any additional notes, that also will be shared after the session. Okay, so you don't need to worry about that. Okay. Okay, let's quickly complete this. Okay, so for what is the definition that we understood, that any year that is divisible by 4. So let's take a year, right? Let's simply take a year as example. Year, let's store it anything like 1993. Okay, so if the year percentage 4, if it is divisible by 4, so how do we check something is divisible by 4? The remainder of it after dividing by 4 should be 0. If on dividing by 4 the remainder is 0, that means it is divisible by 4, and it is not divisible by 100. So year percentage 4 not equals to 100. Okay, so if this is the case, then it's a leap year. If it is divisible by 4 and not by 100, this is a leap year.
0, sir, 0, not 100, sir.
Okay, sorry. Divisible by 100 not equals to 0. Okay, divisible by 100 not equals to 0. If this is true, then it's a leap year. Otherwise, if it is divisible by 4 and by 400, then it is a leap year. Or we can write, or if the year percentage 4 double equals to 0 and year percentage 400 double equals to 0, right? So if any one of these two condition is true, then I can say that this is a leap year, right? So if it is divisible by 4 and not by 100, divisible by 4 and by 400, so either one of this, right? So it is a leap year. So we can print that it is a leap year. Else we can print that it is not a leap year. You can even break this into one single if that does this, then else if that does this. Both of them prints leap year, and the final else which prints not leap year. Okay. Now if you run this, okay, you're going to see leap year and non-leap year. Because it's printing not leap year because 93 is not a leap year, right? But if I give it an input like 96, which is a leap year, so it is going to print leap year, right? Because it is divisible by 4 and it is not divisible by 100. So this particular condition holds, right? Okay. So for which examples it will not give leap year, non-leap year. So for example, year 1700, 1300, these are divisible by 4 but not by 100. These are divisible by 4 and but not divisible by 400. Right, so both of these conditions are false. In that case, we are going to get not leap year. Now you can see that this expression that we wrote over here, it's very like easy to write from this wording, but yeah, a little bit like a very large relational logical expression. We can even break it down using nested ifs, right? We can even write this condition using nested if. So how we can do that? So we can simply check if the year is divisible by 4. If it is, so in both the cases, like no matter whichever case we are trying to print leap year, in both the cases, it has to be divisible by 4. Right. So if the year is divisible by 4, then it can be a leap year. It is not definitely a leap year. It can be. But if it is not divisible by 4, then it is definitely not a leap year. Right. So if a year is not divisible by 4, right, then it is definitely not a leap year. So we can simply print in the else part that this is not a leap year. Now, if it is divisible by 4, what has to be proved so that it is a leap year? So if it is divisible by 4 and not by 100, so if it is divisible by 4 and year percentage 100 is not equals to 0, then it is a leap year, right? It's a valid leap year. System dot out dot println. We can say leap year. Okay. Else. Okay. So if the year is divisible by 4 and if the year is not divisible by 100, then it is a leap year. Else, if it is not divisible by 100, then it is a leap year. But otherwise, if it is divisible by 400, then also it is a leap year. If the year is divisible by 400, year percentage 400, double equals to 0, then also it is a leap year. If it is divisible by 4 and by 400, it is a leap year, right? I simply broke that condition down into two different if else, and at the end, finally, else if it is not divisible by 100, and if it is also not divisible by 400. If it is if it is divisible by 100 and not divisible by 400, right? So in that situation, we can simply print it is not a leap year. Right? It doesn't satisfy any one of the above two conditions for being a leap year, so we simply print not a leap year. Now, the same thing that we wrote over here, which was like such a big relational logical combination, expression combination, we simply broke it down into multiple if else conditions, right? So the first condition is checking whether it is divisible by 4. That means it is a candidate of being a leap year, but it is definitely like not sure that it is right now. We will check the conditions. If it is not divisible by 4, then it is right away not a leap year. Okay. Now let's say it is divisible by 4, then it could be a leap year. What are the other things it has to satisfy? So if it is not divisible by 100, so if it is divisible by 4 and not by 100, so if it is divisible by 4 and not by 100, then it is a leap year. Okay. Okay. What else? If it is divisible by 4 and by 400, so if it is divisible by 4 and also by 400, then it is a leap year. Okay. And finally, if it is like if it is not divisible by 100, if it is divisible by 400, all these conditions are false, then we can simply print it is not a leap year. So for example, which years will get printed from here as non-leap years? Year 1700, 1300, 1800. Right? So these are divisible by 4. So we'll get divisible by 4. Are they not divisible by 100? No, they are divisible by 100 as well. Are they divisible by 400? No, they are not divisible by 400. So we'll come over here and we'll print not leap years. Okay. And for example, years like 2011, 2013. So these are not divisible by 4, not divisible by 4 directly. So we'll directly go to the else part and we'll print not leap year. Okay. And for rest all, either one of these two conditions will satisfy for the leap years, where if it is divisible by 4 and not by 100. So for example, years like this, which will print from here. And for example, years like 1600 to 2000, 2400, these are divisible by 4 and by 400. So we'll print it from here. Okay. So we have a valid scenario for all the kind of years that we have. So for example, year 96 is a leap year. So we print it as a leap year. Year 1700, it is not a leap year. So we should print it as a non-leap year. So it is divisible by 4. It is not divisible by 100, not by 400. And so we print not leap year. Okay. Now interesting, huh? Now that's a valid question. How to write it in ternary operators? You can just put a question mark on this, and then you can say yes. So just need to put a question mark after this, right? So this is like the expression. If we just want to get a leap year or not, so let's say, so let's store it in a Boolean value. Boolean b is equals to. We can simply do this. If this is true, so then we can put true. Otherwise, or we can simply put this, right? We don't need to put true or false. So this will be, if this is true, then it is a leap year. If it is false, then it is not a leap year, right? Or if you want to store like a string or something, then you can do ternary operator and you can put like leap year, non-leap year or something like that. So let's say you want to get the string. So you can do string s is equals to, and you can put question mark leap year. Colon, not leap year. Okay. Understood. Same condition, or if you want to break it into nested ternary, that also you can do. That would also be like similar to doing this, where you check if it is divisible by 4, then you have chance of it being a leap year. Otherwise, it is definitely not a leap year. How to practice ternary? Okay, practice ternary is like writing this thing in ternary. So this was easy, right? So this was you directly copy the expression and you write it. But how to write it in this way? Nested. If you try to convert nested if into ternary, if you are able to do that, then you will be successfully able to understand ternary. Okay, let's try to do this one using ternary. So what we are checking? So we are checking one condition at a time. So we are checking if year percentage 4, if this is double equal to 0. Okay, then it can be a leap year. It may not be a leap year. But if it is not, then it is definitely not a leap year. So we can say not leap year. Okay. Understood this part? Okay, I'm just writing the else wala part first. If this is false, then it is definitely not a leap year. That is this else. Okay. What else from if it is true, then if it is true, then we again have multiple conditions. That what is the condition? If the year percent is 100, if this is not equal to 0, okay, or let me club this one, so this looks little bit easier. Or if the year percent is 400, if this is equal to 0, right? If any one of these two condition is true, right? If any one of these two condition is true, then it is a leap year, right? So we can, if this is true, then we can say it is a leap year. Okay. Or else it is not a leap year. Understood? Instead of string, you can use boolean. That's also fine, right? So I just told you, right? You can store the answer of any relational expression or any logical expression in boolean. So that will all get you the correct, true or false value. Okay. See, we did the same work. Here we wrote multiple conditions, right? If like in a single if, like in a single part, and then we checked if this is true, then it is leap year. Otherwise, it's not, right? Now here, see what we have done. We just wrote. So this was easy. This was like writing this first part. Okay, let me just print this one first. So let's do one thing. You can even directly write it in system.out.println without storing it in a string as well. That would also work. Okay. So if I run this, see. So what it is doing, it is definitely like it is just trying to do what we were doing in the if condition. Okay, whatever is the result that's coming from the if condition that you would get from here, you will directly get the same thing from here. We have not done anything additional, right? We have just copied this expression. If this is true, we print leap year. Otherwise, we store non-leap year. Okay, there was no magic over here. But okay. But what about this nested one? So this looks a little bit different. Yes. So here we have done some work, right? So what did we do? So we tried to write how the nested condition was written. So what we did in the nested condition, if this is divisible by 4, then what we have done, if it is divisible by 4, then there is a chance of it being a leap year. So from here till the first, like it's in the last column, right? So this part means it might be a leap year, it might not. We'll check, right? There are additional conditions to check, but it can be or cannot be. But if this is not true, then it is definitely not a leap year. So that's why this part, that it is definitely not a leap year. Okay. Now, what is this? So here we wrote another nested ternary condition like we yesterday wrote to check if is like out of 3 numbers, which number is the greatest one. So same thing we wrote over here, that if this out of these, if it is divisible by 4, then it can be. Then it should also satisfy year percentage 100 is not equal to 0 or year percentage 400 is equal to 0. Right? So if any one of these two conditions are true, right, that means it can be a leap year. Right? If any one of these two conditions are true, that means it can be a leap year. Otherwise, if this is not true, then it is definitely not a leap year. Right? So it is similar to me writing these two conditions using OR. Right? Or को use करके I've just clubbed these condition over here. Okay. So either you can write it in else if or you can write it using OR, right? So else if is similar to writing OR. Okay. Understood. So that's what I have done over here. If you want to break it into again multiple nested if, you can create one more nested chain. That is also fine. If this is divisible, then it can be a leap year. Otherwise, if this is not true, then you can write one more ternary. So let me show you that way as well. Show you. Okay. So what's the other way? So this way is like little bit more tricky. See, just have to follow step by step, right? So first, if this is true, then it can be a leap year. If this is not true, then it is definitely not a leap year. Okay, we got the first part. What's the second part? So second part, we'll check this one. So if it is year is divisible by 100, that means it can be a leap year. If it is divisible by 100, then it is a leap year, right? If it is divisible by 400 and not by 100, then it is directly a leap year. But if it is not divisible by 100, then I cannot say it is not a leap year. It again could be. So what we have to check over here, we'll again check if the year percent is 400, if this is equal to 0, then it is a leap year, or else it is not leap year. Okay. Now I would say this is a very, very bad code. I would never approve this kind of code in going into production. The reason being, this is completely not readable, right? So as an engineer, we should write code that is readable, not something like which looks complicated, does the work. The code should be as simple as like it can be in the most optimal time, so that you can, any other developer can just read it and understand what is happening over here, right? So this is an unnecessary complication that we are creating over here, which could be done in simpler ways, like using this. So this is like at least even simpler than this. Okay, this is like the simplest one. I'd still say if you are going by ternary, but yeah, this is even simpler, right? I would say this is also even better. So that is there, but this is like way complicated, right, to understand. So if this is true, then this is true, then it is leap year. Okay. So we do this. Otherwise, if this is true, this is false, then we go here. We check this one if this is true. Why not leap year 2 times? So not leap year 2 times, same reason why we have printed not leap year 2 times, right? So if none of these two conditions satisfied, we told that, okay, even though it is divisible by 4, it is not a leap year. And if it is not divisible by 4, then it is not a leap year, right? The same logic here also. If it is not divisible by 4, then it is not a leap year. And if it does not, it is divisible by 4, but it does not satisfy any one of these two conditions, then it is not a leap year. Okay. So you can simply break it down step by step to like, so 1700 is not a leap year. Okay, it's correct. 1996, it is a leap year. So it should say divisible by 4, not by 100. So it is a leap year. Right? Shell works. That's the job. See, you just have to think one small problem. You try to write this entire thing at once, you will probably not. So how you can think is, see, firstly, you have to not think about this part. You just have to think, if it is divisible by 4, then what's the scenario? If it is divisible by 4, then it can be, it is definitely like, I cannot say with concreteness this is a leap year, but if it is not, then it is definitely not a leap year. So I can firstly fill out the else wala part that it is not leap year. Okay. Now, if it is divisible by 4, then what we can do? So let's try to find this one. So let me remove this part now. Okay. Now look at this one. So if it is divisible by 4, I wrote one condition that it is, if it is not divisible by 100. Okay. If it is divisible by 4 and not by 100, then it is definitely a leap year, right? If it is not divisible by 100, then so if it is divisible by 100, then we'll check, right? We cannot say that it is not a leap year. For example, year 2000. Okay, that is divisible by 4. And it is also divisible by 100. So it will not satisfy this condition. We'll go to the else part. But for example, year 1996, it will be first condition is to divisible by 4, and it is not divisible by 100. So this is also true, right? So we can say directly it is a leap year. Okay. Now let's say it is divisible by 100. So what's now what's in the in that scenario? So we'll check this. If it is divisible by 400, or if it is divisible by 400, then it is a leap year. Otherwise, it is not a leap year. So this is exactly what we wrote over here in nested loops. Okay, understood here? Okay. Okay. Yes, so there are like a lot of questions in the gym as well where you can practice this. So there are conditional questions tagged with conditionals, if else, right? So that you can practice. Or one way I will say is, every time you see a complicated if logical expression like this, right? To try to, for now, try to solve them using like nested if, and then try to solve it using ternary operators. So you'll understand all three of them, right? So see, you can find the easiest solution. This is the easiest one, right? This is like, okay, this is still easier, not very difficult, still easier to understand. This is like most difficult one, right? It is like most difficult to understand, but still does the same work, right? So you can try to write these complicated expressions yourselves and test whether it is working fine or not. And how you can test it even in better way. You don't say just uncomment this, you know that this is correct, this is 100% correct, or this is 100% correct. Write the ternary expression. You just run both of them simultaneously and check whether both of them are giving you the same result or not, right? So whatever you're getting from here, you should also be getting from this. Then it's correct. And check for different inputs, right? For when it is printing non-leap year, leap year. Yeah. So there is no proper syntax. This is the proper syntax, right? Question mark and colon. I have written that syntax over here. I'll show you just. So, okay. Understood. Firstly, tell me this part. Nested if, logical expression, ternary expression, how you can do it in different ways. Okay, how you can break it. So that's why I love this question of leap year. This is like one of the basic problems, but it It can be solved in so complicated ways and so easy ways that it helps you understand everything about logical relational operators and nested if. Right. So everything that you need to know is just one single question that it covers. Okay. Now coming to like, so this was nested if, and then we saw the case of dangling else, right? So dangling else is a very interesting problem where if you don't have brackets, then the if or else part can have only one single statement within it, right? Now, this is not a problem when you write single statements, but if you write like nested ifs, it becomes a little bit tricky of to which if this else would belong. Right? Let's say if you don't have this else altogether, then to which if you will put this else. So this will always go to its immediate if, okay, until you specify using brackets. So it will always get associated with its immediate if. If it is not able to find any immediate if with which it can associate itself with, so it will give you error that this else is without any if. Same goes for the else if wala part. Okay, so that's the case of dangling else where the else belongs to its immediate if. Okay. Okay, so we saw the logic of finding the largest number among three, and like keep in mind this equal to, right? You students generally forget, but keep in mind this equal to scenarios because these are the small kind of things that you will that interviewers will notice while interviewing you, right? So like it would look like a very he would not ever ask you to write a like logic or to find out the largest among three numbers. He's never going to do that. He's definitely going to come with some other question where this kind of logic will be used, that you have three numbers and you have to find out the largest among them. Okay, and then you would need to do some other logic. And here you have to be careful while finding out these largest of that equal to, right? Because he will immediately be noticing that whether you are using equal to or whether you are using just greater than less than. Okay. And we also saw if there are multiple equals to and you want to get them separately, how can you get them? Okay. Then we understood about ternary expression, the same thing that we use right now. So this is the syntax of it. You write condition, question mark, then what's the first expression, and column the second expression. You can store it in some variable. If you can write this entire thing inside println, so you can print it, that was fine. So what is ternary expression exactly used for? So ternary expression is used for solving smaller things, right? So for example, a greater than, if a is greater than 10, we want to print greater, otherwise lesser. So it can be used to do this smaller things, right? So we generally use ternary expression to get the smaller thing, not not try to solve complicated ones. Complicated logics like these, we write them using relational or logical expressions. But yeah, it can be like ternary expression can be created to write complicated logic as well. Okay. Now, okay, so this first expression runs when the condition is true. The second expression runs when the condition is false. Okay, simple as that. True and then false. So here we wrote like if a is greater than 5, then we want to give b the value 10, otherwise 50. So that we wrote. Now, if you have like three numbers, we want to find the largest among them. We wrote a like condition how we can find out. So if a is greater than b, if a is greater than c, then a is largest, definitely. If it is not, then there can be choices. Either b is largest or c is largest. Now, whichever one is greater, that is the largest one. Okay. I even gave you one assignment to solve this one. So did anyone try to solve this thing using ternary? Is it too complicated? I guess now since I solved that one, how to break it down. So just have to write one condition at a time. You don't have to worry about so much all together, right? You have to write one condition at a time. Okay, try it today. I'll not share this logic right now. Okay, try to get the correct answer yourselves. I gave you the logic of how you can break it, right? So I gave you how you can break it step by step, right? So you can just need to think it step by step, like we wrote over here. One condition at a time. If it is false, what's going to happen? Or if it is true, then what's going to happen? So whatever you are certain with, if it is false, then this is there. If it is true, then what you have to do? That's you have to figure out which one. One of them will be definitely clear always. So for example, look at this situation. Right. So here, what is there? If this condition is true, let's say, okay, and you are checking this first, then you directly know that A is largest. You don't need to check anything else. But if it is false, then you have other conditions to check. Then you can check this one, right? So you can check the condition like this. Then if this is true, then B is largest. Otherwise, you have other conditions to check, and you can keep on doing question mark or you can keep on doing. Okay. And then the last type of conditions we learned was switch case. Okay, Siva, if that's cleaner, then it's better, right? I always prefer to write clean codes, right? Yeah, I've learned a lot from like the PR reviews, right? So senior developers are very, very keen of doing this. They never approve any PRs which doesn't look clean or where the code is not understandable. Okay. So okay, now then we learned about switch case, where we have like it's also like a condition, but this is like a very specific case condition. You cannot use it in all the situations, like having complicated relational or logical expressions. All those things doesn't work. It is like a direct comparison thing, right? So we have a value and you just compare it with some other value. So here you have some variable and you are just trying to compare its value with some other constant values like 1, 2, 5, something like that. Okay, so you're just trying to compare it with constant values. That's it. Okay. So if the comparison is true, then you just print this statements. You run this until you hit a break. And like if it is false, then you just go to the next case. If finally if all of them are false, you can have a default one similar to writing else. And this is also optional. You are not required to write a default case. This is also optional like else part. If there is a default, it will run it. If there is no default, then it is not going to run. There is one unique case which is known as fall through. Now what happens over here is if one of the conditions is false, one of the conditions is false, we go to the other condition to check, right? But if one of the condition is true, until we hit a break, we keep on running the conditions. We keep on printing, keep on running the conditions. So if we have multiple conditions, if we don't have break over here, let's say, so what will happen is if any one of this is true, we'll keep on printing until we hit a break, right? So all the other condition, irrespective of whether they are true or whether they are false, we'll keep on printing them until we hit the break. Okay. So this situation is known as fall through, where you have where all the conditions run irrespective of whether they are true or false, right? Can we write switch case using ternary? Switch case using ternary, what does that mean actually? Yes, okay, sure. If we, like if there is a new version, right, that is introduced something new, but still it won't be violating anything that's there in the older version, right? Because it's a very fundamental thing. And it would be used into advantage. For example, this optional chaining that we use over here. So this is like, this happens only because of fall through, right? So for example, here we have case 2, case 5, or case 10. So how it is executing? This is executing because of the fall through situation. If one of the condition is true, we keep on running until we hit the break, irrespective of what the other conditions are. Right? So this is working because of the fall through situation, right? If there is no fall through, then this won't work, right? So that's it. That's what we learned in yesterday, which was conditionals. Now you can create complicated conditionals using this. These are the only tools that you have. There is nothing else apart from this. Logical operations, relational operation, ternary, if else, or switch case. Okay, so these are all the things that's there to create conditionals. Okay, there's one interesting thing that I forgot to mention about over here. So let's say you're trying to do this. Okay, and I have three values. Int x is equals to 1, y is equals to 2, and z is equals to 3. And I like write it as x, y, z. Okay. Now if I run this, looks like a simple plain comparison where we have a values, b values, and c. See, this will not work because you will get an error, constant expression required. Okay. So the thing that you're writing over here has to be a constant value. Okay, it cannot be a variable. Okay, so you can directly write the value. So these are constant values, directly the numbers or anything. Like if it is comparing with a character, you can directly write the character, or if you want to compare it with strings, you can directly write the string as well. Okay, that is also fine. You can write that as well. That is also fine, but you cannot write a variable name. Okay, that doesn't work over here. Now, is there any way altogether to get the variables working? Yes, there is. So we can convert our variables to constants. Okay. So what are constants? So constants are like, okay. So in Java, we use a keyword known as final. What does this do? This converts the variables to constants. Now, if I run this, it will work in this, like it will work to print it. Now, what's the difference between the previous variable that we wrote and what's this final keyword, what it is doing? So once you write final in front of something, then if you try to update this variable anywhere, okay, So it will not allow you to update this. This will tell you error that cannot assign a value to a final variable. That means in normal variables, you can update their value as many times as you want. There is no restriction, right? Whatever you want to do with that variable, you can do. But once you create a variable, you specify it as a final variable. That means it is a constant value. You cannot update it. Okay. Yes, it is constant. So this is present in other languages. The keyword that you use in C++ is const to make any thing constant. Here we use that final. Okay. In JavaScript or TypeScript, there also we have constant. Okay. So that we use as const. Here in Java, we use a keyword final to make it like a constant value. Okay. So let me write the final. So this makes the variable value constant, and so that it cannot be updated in the code. Okay. So you cannot update this variables in the code. Now, why do we require such variables which cannot be updated, right? What is const variable? Constant variable is a variable whose value can never be changed, right? We use the keyword final to make any variable constant. Okay, so final is a keyword that makes the value of any variable constant. Okay, so you just have to write the normal variable, right? How you declare variable, whatever you're doing, you just need to add the keyword final. Now, what is the difference between normal and this? The normal variables you can update. So, for example, if I write a equals to 10, there is not going to be any error that we are going to get. If I run this, it's going to still work fine. Okay, there is no errors. Okay, you can assign the value of normal variables as many times as you want, but you cannot change the value of a constant variable. Okay, so you cannot do this. This is an error. You cannot do this. Okay, so you cannot update the value of any constant variable, whereas you can update the values of normal variables as many times as you want. Okay, so this is the difference between them. How do we make constant? We just add the keyword final, which says that the values of these variables are final, you cannot update them. Here, in case of case, either you can write constant values, which is like directly numbers. So these numbers are by default constant values in the code. So if you write directly as numbers, it's going to work. There is no issues. But if you're writing variables, they have to be constant values. So how can you make variable constants? You can use the keyword final to make the variable constants. Okay. Understood this logic? What is constant variables? Why we need final? Yes. Now, why do we? So final is making the variables constant over here. So here it simply says that these values has to be constant. You cannot have variables which are changing values, because it switch case conditionals are created in the compile time of how it is going to work, right? If the values are changing or updating in the code, then it won't be able to compile them during the run, created in the compile time itself. Okay, it will be a runtime execution that is happening, for example, in case of if condition or something. The switch is a compile time process, and it cannot do if the values are not constant. Okay. Now, what are the other uses of this constant values? So in software development, we use it a lot. So any values that we don't want anywhere to change, we want all the developers to use the same values, we create them as constant values. So for example, let's say there is some number that we don't want to change. We want to always show it as a constant value. Right. So that is pi can be one example. If we are using calculation somewhere in pi, so we want the pi should be constant throughout our software, right? Someone is using 22/7 and someone is using 3.14, it should not happen, right? So for example, if we are doing something, let's say we are calling a particular particular domain, let's say we are calling google.com. Okay, so to search something, so everyone should be using google.com. It's not like someone is using google.in, someone is using google.com, someone is using Bing, someone is using ChatGPT. So that should not happen. Okay. Finally used as the same purpose as you use const in other languages like JavaScript or in C++. Okay. Understood? Clear? Okay, so this is one thing that you get. So generally, this is one error, like very common error that comes. So for example, you will be given input output questions, and you will there will be a missing final keyword. Okay, and it would have simply asked you what's the output of this. It would have given even a fall through situation. So you would see that, okay, this is a fall through question. It is not, and everything is looking fine. But there would be one small option in the MCQ that this code would give you error. So you would say why it would give error. There is no syntax error, right? Even if there is missing break. So you would think that, okay, error is given so that if someone doesn't know that you can remove breaks from the switch case, he would think it as an error, right? But it is actually not an error. But here it is actually an error because the final keyword, if it is missing, that means this is an error. This is not a valid switch case, right? Okay. So how you think the questions are just created around them, right? If you don't know a particular concept, then it is 100% you are going to make mistake on that, right? Clear? Okay. Shall we proceed to loops? Is conditional clear? Hmm. Uh, ChatGPT, is it going to replace developer? Okay, let's talk for a minute. Okay, before I start with something new. So see, it's not going to ever replace developers. Like, being honest, it's not going to replace developer because see, the code that we write is way complicated than it seems over here from basic programming. No matter like how complicated DSA you write, the code that you'll write in actual software development, where all the like good software engineering practices are followed, that is way more complicated than any AI algorithms can write, right? I don't think even they would be able to do that in very future because we ourselves have programmed those AI, right? So we know that what the limitation. It cannot think like a human, right? It can try. It only thinks from whatever data we have given to it. So let's say if we have given it hundreds of data, ChatGPT, what it does, it has numerous amount of information that it can remember that we can't remember, right? So whatever information we have given it, it can remember everything. But like for example, but it does not can create human based decisions, right? Like we can do. So we can think of like human based decisions that it cannot do. So can it not create a switch case like this? Can it not be able to know that this is an error or something? Or can it not create this if else logic into ternary operator? It can all anyways do, because this is a very basic example. This is a very basic question that we are asking to the AI. So that it can definitely do. But in real software engineering, where we are solving very challenging and complicated problems, for that it won't be able to do it, right? Now, ChatGPT even makes so many mistakes. So yes, there is a new version of it. I guess you would not be knowing. That would be out by this month. Okay, so that is Bing plus ChatGPT. It is way more advanced. So if you have used the trial version of ChatGPT that was there online, it is 10x more powerful than it. And trust me, I have used it, and it's so good that it's like rarely there is any error. Okay, and it is like way advanced than the ChatGPT that was there available for online, right? So that was like very basic version. Now the version that's coming out with Bing, so that's known as Bing Chat, right? In the Bing search engine, you'll get an option to Bing Chat, and there it is like way advanced than anything like out there. So if you are used to doing things using Google, and once you try to use that, there is no going back. That's me. That's the online version that's available for like the chat GPT one that you have available from OpenAI, that's different than what you would see on Bing or something where it is actually used. Okay, so right now you would also see something known as Copilot that's also coming. So there also it is like way advanced than what was there in the trial version. Okay, so there is one YouTube video as well that Microsoft has made public. On review, there are like trial reviews also you can do by getting waitlisted for now until it becomes live for everyone. So I can join that waitlist for the chat Bing option, and there is like it's more powerful than anything. So is it going to solve some problems? Yes, it's going to solve a lot of problems. For example, article writing, mail writing, or all the work of like copywriting, creating content, getting ideas for something. All those things would become very easy using ChatGPT. If you want any piece of information, let's say you have a basic search query, you want to search something like what are the winners of IPL teams in a tabular format for each year. Okay, so if you search the same thing in Google, what Google would do is Google will give you a Wikipedia link. right? Wikipedia has a very big page about IPL, and there would be somewhere it would have a table where there would be the winners and having a lot of information about the winners, which team won, when it won, what was the date of the final, which was the runner up, and so on and so forth. Much more unnecessary information. From that, you have to take out the necessary information. But if you give the same query to ChatGPT, it would right away give you the table that you are asking for, and whatever data that you are asking, the winner, the year, let's say the runner up. These are the three data. So it will give you the table in just having those three data itself. Okay, so that's how like it reduces your effort of finding something on the web. So till now, whatever searches we were doing, we were used to searching something, and we used to get the links of site which used to have this information. Now it was our role to figure out from that site what is the information that we asked for. That you have to crawl through those sites, you have to browse through, right? If link one is not having that insert, you go to the link two and so on. But in ChatGPT, it tries to find out the best answer that's there, and what you are looking for, it will directly give you that answer, not the links. It does not give you the links that these are the sites and you find your answer yourself. It is going to give you the answer right away, which is way more accurate. Okay, now then anything that was there. So that's like how good it is. Is it easily prone to hacking? A number rotation I'll discuss, right? I'll discuss a loops question, so I'll discuss it. Okay, so we'll discuss this thing. So this was interesting, like it's interesting, it's there. It's definitely going to change how we search things online, definitely going to impact, right, how we are used to searching, because once you go to the ChatGPT mode of searching things, you'll never come back to the way of Googling that we are used to. Okay, so that's how big the difference is. Let's see, right? It's again very new. Let's see how we get used to it, how like we have got used to Google. Okay, it will definitely learn, right? It is definitely going to improve. Website development will decrease. I don't think so. Websites would still keep on developing, right? It's keep on going to work that way. Okay, so let's come back to loops. Okay, let's start by our understanding of programming so that we can work on building things like better than ChatGPT, or things that ChatGPT cannot build. Okay, let me put it in that way. So that way it looks more interesting. Okay. Okay. So we have loops. Now, what are loops? So we have everything till now. We have variables, we have data types, we have conditionals. So we can write logic, we can write some conditional based logic. So why do we need loops? Okay. So let's say I tell you to print hello world one time. So say, oh, so this is easy. I'll just do system.out.println hello world. So I'll say, okay, it's fine. What about if I tell you to print 5 times? I'll say, oh, sir, this is still easy. I'll just copy it and Control V, Control V, Control V, Control V. I pasted it 5 times, so it will print hello world 5 times. What if I say 100 times? So, okay, sir, you're asking me to do a lot of work, but still not too much. I'll just copy these 5 lines together. Now I am smart. I'll paste these 5 lines. It becomes 10 lines. I copy them. Okay. And then I can paste these 10 lines and I can create 100 lines, right? So I can get 100 lines of hello world. Okay. Now, if I say you to print it 1 million times, then you say, okay, sir, now that is a lot of like too much of copy paste. There should be something like which should be better, right? We want the machine to do the work. Why we are doing the work? So there comes the role of loops. If you have something that you want to do again and again and again, you can write a loop that will run a particular logic again and again. You can change the variable values or something that you want in every different iteration of loop. But if you have something that runs again and again, you can write it using loops. Okay, so there are different kinds of loop. I'll start by one of the very basic ones, which is like which has everything. So the for loop. So the for loop has 3 parts, actually 4. So first one is initialization. Then we have condition. And finally, the updation. Initialization, condition, and updation. Okay. And then we have the body of the loop. Body of the loop. So we have initialization, we have condition, we have updation, and we have a body of the loop. Okay. Now, what are these 4 parts and how does these things run together? So the loop runs in a cycle known as ICBU cycle. So firstly, we run initialization, then we run the condition, then we run the body, then we go for the updation. Okay, and then we continue with, after we are done with updation, we keep on checking the condition, body, updation. We keep on running this until the condition becomes false. Okay, so we keep on doing the condition, body updation until the condition becomes false. If the condition is true, we'll keep on doing it until we see a false condition. Okay, so once this condition becomes false, we come out of the loop. That's the only way to come out of the loop, if the condition becomes false. Or there is one more way, like which is breaking loop in between. So for now, let's stick to condition becoming false. Okay, so if the condition becomes false, we come out of the loop. We call this cycle as the ICView cycle, where we keep on running any loop until we hit this condition false. Okay, so now what is this initialization condition or updation? So you have so what is initialization? Initialization is basically where we are going to start. And so this initialization runs only once. We run the initialization condition, initialization part of the loop only once. That is at the start when we start running the loop. So we run it only once, and then the other parts run. So if there is any statement that you want to run only once, any value, any variable that you want to create, so that you can do over here. Now condition is something which you want to check. So let's say we want to run this loop 10 times or something. So we can check until the condition is true, we'll keep on running it. Once the condition becomes false, we'll terminate the loop. Then we have a updation, how we want to change the value of I. So see, if we gave a value 1, we are checking the condition. So 1 is less than 10, that will always be true, right? Until we change the I value. Until we not change the I value, the condition is always true. So if you don't have an updation, then the condition is always true and the loop will keep on running, it will never end, right? But if we change the value, so what happens is the condition changes, and after some time it becomes false as well, right? So if I run this, what would happen is, firstly we did the initialization, we get the value as I equals to 1. Okay, then we check the condition, 1 is less than 10. Okay, that's true. We go to the body, we run the hello world. Okay, then we go to the updation part. Updation, we are updating the value. We are using like this way, how we are updating it. So we are writing I equals to I plus 1. What does this actually mean? So let's say I value was equals to 1. Okay, so what I've written, I is equals to I, which is 1 plus 1. So I value become equal to 2. So this is 2, and where we are storing it? We are storing it back into I. So we are basically changing the I value to 2. Next iteration, when we are writing I plus 1, so we are writing 2 plus 1, which it becomes 3, and we are storing it back into I. So this value we are changing it to 3, then it to 4, then to 5, and so on. So we are just changing the value within I by increasing it by 1 from its own value. Okay, so that's how we are updating it. We can write updation in any way, right? We can write plus 2 plus 3 multiplied by 2 multiplied by 3 and so on. Okay, we can do updation in however way we like, depending on the updation. I value will change, and if the condition is true for those values, the new value that you are getting will keep on running until the condition becomes false. So you update it by 1, 1, 1, and so on. So if I value is 10, the condition is true. Once I value becomes 11, so the condition becomes false and we come out of the loop. Okay. Now, first question, how many times is this loop running? This loop part, how many times it is running? From 1 to 10, 10 times. Okay. How many times is this condition getting checked? So the condition is getting checked 11 times. Why? So there is last one condition which is false as well. So that is also getting checked, right? So the condition check always happens one additional time than the number of iterations that you have in loop. If the loop is running 10 times, your condition check is going to happen 11 times. Okay. Now, before proceeding, let me cover one small thing. Okay. Okay. Let me write it before loops. This we call as increment and decrement operator. How many of you know it? Increment and decrement operator. Used it? Yes. Okay. I guess this would have been done. So let me show you the interesting part of it. Okay. So what is increment and decrement operator? This is a shortcut way of writing increment and decrement, right? So you have plus plus and minus minus. So plus plus says basically, okay. Okay, since I have covered ternary, I can cover this part as well. So before going into this, right, let me firstly cover this part. Okay, then I'll explain you something about operators. Okay, so let's say we have a is equals to 5. Okay, so we can actually do increment on a. We can print a increased by 1 by writing a plus plus or plus plus a. So this is increment operator. What does this do? This increases the value of a by 1. Okay. Now this increment and decrement operators can be written in two ways. One is pre-increment, okay, and other is post-increment. And then now there is a very big difference of how it works in both the cases. Both of them are supposed to increase the value of it by 1. Okay. So if I write something like plus plus a, this is pre-increment. But if I write something like a plus plus, this is post-increment. Okay. Now what's the difference between them? So for example, let's say I have a equals to 5 and I run this logic where I'm writing plus plus a. Okay. So when I'm writing plus plus a, it is increasing its value by 1, 6, and we are seeing 6 as result. Okay. If I just write a anywhere after it also, so it is actually not just printing it over here, it is actually changing the value of a. Okay. So if you use it anywhere after it, it is also going to have the updated value, whatever the increment or decrement operator updated it. That if I write it a minus minus a, it is going to decrease its value by 1. Okay. It is increases or decreases the value of a variable by 1. Okay. So it increases or decreases. It is similar to writing like this: I equals to I plus 1, or a equals to a plus 1, or a equals to a minus 1. So this is simply evaluating to by writing something like this. You're writing a plus plus a. So this is evaluating, this is equivalent to writing this: a is equals to a plus 1. Okay. So the expression that we wrote over here, can we make a variable constant after 2-3 updation? No, we cannot do it. If the variable has to be made constant, it has to be made at the time of declaration. We cannot do it after updations. Okay. We cannot change the type of a variable after doing some operation. Okay. Okay. So we increased it, we decreased it. Okay. So this is what pre-increment and pre-decrement is. Okay. Now, limit to variables? No. I don't think there is a way to set limit. Might be some like some higher order programming or higher order function using which you can do, but I don't think there is a way to limit it. Okay, you can create objects and using that you can limit what's the value that you can put, but right, like from the inbuilt data types, I don't think there is a way. Okay, see, now what's the difference of this post increment and pre increment? So when I was doing pre increment, I was seeing 6 values both the places. But when I'm doing post increment, I am seeing the value 5 over here, and then I am seeing the value 6. So what does post increment and pre increment do? So pre increments updates the value there, and it firstly updates the value, that whatever is the current value, updates it and then uses it. Okay. Post increment works a little bit different. What it does, it firstly uses the value. Okay, uses the value that you have and then updates it. Okay. So pre-increment firstly updates the value and then uses it. Post increment firstly uses the value and then updates it. Okay. So see, so now this is a very big difference that it causes. For example, if you are printing a plus plus, so this would print the current value, which is 5, and then it would get updated to 6. So after it, if you use, right, it will have this value 6. Now, I think I'll come to the loops part, how it is working there and what pre-post, how it can, what are the difference that it causes. Okay. But this is how pre and post actually works. So the value that you are having currently over here is going to be the current value in case of post, and then it is going to get updated, and then you, wherever else you use it, you are going to have the updated value. Okay. In case of pre-increment, you will have the updated value there as well, and after it, you will always have the updated value. Okay. Both of them applies in the case of like increment and decrement operator. First, tell me understood this part. What is pre and post increment? So pre updates it, then uses it. Post uses the value and then updates it. So any later occurrence of it is going to have this value. So what are the like interview related question that you get from here? So there is a very interesting, and this is like a direct interview question that you get from here. Is like there in almost all of the company technical rounds, you are going to definitely have one question from increment and decrement, which is going to look something like this. Okay. So there is a value a. Now you would be given to do something like this: plus plus a plus a. So let's say you're given this, and you're asked to find out what's the result of this. what's the final value of A, what's the final value of B. Achha, tell me what's the result, what's the final value of A, what's the value of B. Plus plus A plus plus, no, that's not valid. Now you all are telling different answers. 17, 18, 19. So let's check. Okay, see, A value is 5. So let's start from there. A is equals to 5. What is B? So A plus plus, what we are going to get? So we are going to get the current value of A and then we are going to change it. So it is 5 currently and then we are going to change it. So 5 we got over here and then we change it to 6. Okay, plus. Next time I'll see A, it is having the value 6. Now I updated the value of 6 by 1, it became 7. Okay, here it became 7. I used 7 over here. So in case of in case of post, we use the current value and then updated it. In case of pre, we first updated the value and then used it. And then finally plus A, so A is 7. So 7 plus 7, 14. 14 plus 5, 19. So B value is 19 and A value finally is 7. So the final result of this thing is 7 and 19. Okay. Understood? Okay, let me give you one more to solve. So are you going to get it this simpler? No, it's definitely not going to be this simple. Now tell me what's the result of this. Let me clean it out so that you can see the question. Do it step by step. Right? Always remember the rule of running a program, never skip steps. You'll never make mistakes. If you skip steps, you are definitely going to make mistakes. Fifty, 51, 7. Even 40. So now the output is varying from 40 to 51. So let's see. So see, I'm not running it. See how I'm solving it, and we'll exactly match of what this system is going to give. Okay. See, so firstly we are going to have 5. So A value is 5. Okay. Now we are wanting to find P. Okay. So I've written plus plus A. So A value firstly changes, becomes 6. Then we check the value 6. Then we have post increment. So firstly we take the current value, which is 6, and then we increase it to 7. Okay. Done with this. Then we have one more plus. We have A plus plus. So we take the current value of A and then we increase it to 8. Okay. Plus we again have a plus A plus plus. We take the current value of A 8 and then we increase it to 9. Okay. Then we have plus minus minus A. So what is minus minus A? We'll first decrease it. It becomes 8 and then we take the decreased of it. We take A finally plus minus minus A. So we'll firstly take the current value and then decrease it by 1. So it becomes 7. So A value finally is 7. What is the B value? So 6 plus 6, 14. 8, 4, 4, 8 is 32. 32 and 14, 46. 46, 7, 51. 46. Sorry, 32 plus 14, 46, 47, 46 plus 7, 53, right? Is my addition wrong? Okay, 51. Let me check where did I go off. So this is 12 plus 7 plus 8, 432. Okay. Oh, this is take a 51. Okay, sorry. Addition is longer. Okay. Okay. Got it. You did 6 plus 6, 14. Thanks. Okay. Clear? Understood? I can solve these kind of problems. So this is one kind of problem that is like very common that appears in the online rounds of companies where you get MCQs. So this is one of the very common questions. So in input output question, there is definitely going to be one question from like increment decrement operators, one from like if there is from conditional, so it is either going to be fall through or anything else. Okay. Understood? Clear? Okay. Yes, no. You want to do one more? Or are you all confident you'll get the correct answer next time? So let's do one final one, and I hope all of you get the correct answer this time. And we can proceed, right? So do this one plus a minus a plus okay, try to find for this one. Short one, easy. It's just minus. I want a single answer from all of you, or not this much varied answers. Single answer. So let's check them. Okay. So minus 3. Out of you are getting minus 3, minus 1. Is it negative? Might be negative. I guess it's negative. Okay. So let's say A is equals to 5. We are doing plus a, which is 6. B is equals to plus a, which is 6. We first increase it and then use it. Plus a, which is 7. So first increase it and then use it. Minus. Okay. A minus. So we use the current value and then decrease it by 1. It becomes 6. Okay. Then we have plus a plus. We use the current value and then increase it by 1. It becomes 7. We have minus a, which is minus 7, minus. We have plus a, so it becomes 8, and then we use it, so it becomes minus 8. Okay. Now plus 7 minus 7 cancels out. Okay. So 6 plus 6, 12, minus 7 plus 8 plus 7, 15. So it is minus 3. Okay. So minus 3 and 8 is the result that you should be getting. Okay. 8 minus 3. Understood? Okay. So there is no shortcut to solving this. You have to do it step by step, slowly, at one value updation at a time. If you try to do multiple steps, or you try to do it without writing, you are going to make issues, make errors. Okay. So try to write this, what's the expression that's forming, and then try to calculate the value. Okay. Clear? Yeah. Now, coming back to the loops topic. So in case of loops, here we are writing I like I equals to I plus 1. You would often see if this is written as I plus plus or plus plus I. Right now, we like people prefer it writing in different ways. Why we get 8? infix, postfix, that we'll learn later. Okay, okay, let me complete this. Okay. So how did I get 8? Just look at it, how we updated it, right? How we are updating it. So at the end, we did a plus plus a, right? So it increased from 7 to 8. Infix and postfix, not right now. We'll cover this. There is a question in stack, so there it will be covered. Okay, so infix and postfix wala part that will be covered in the time where you will learn about stacks. Okay, got it. Okay, is pre-increment, post-increment, pre-decrement, post-decrement. Is this clear completely? Can you solve any questions now on this? Okay. I want that confidence. Take it. Okay. Next. Now here, what do we do we use it over here? Yes, we use it in loops very often. You would often see it written in plus plus or I plus plus or plus plus I. Now, does it cause any difference in running loops? Actually, it doesn't. Okay. Why? See, why it is not causing any difference? Because the loop is not running based on the updation. The loop is running based on the condition. And condition is a different part than updation, right? So if wherever you are doing updation, you are checking the condition somewhere else. So even if you write I plus plus, here you are doing updation right now, here I value might be different, but later it got changed. Whenever you are doing this condition check, that time it got updated to whatever value you wanted it to be. So the condition is checking, a check is happening correctly, right? So even if you do it plus plus I or I plus plus, both of them works in case of loops because the condition check is happening at a different place, not here. Okay. Understood? So basically the condition check. So see, whatever is the next place where we are going to use I, that is definitely going to have the updated value, right? No matter you are using pre or post, there it is up right now. It might be different if you use pre or post, but later if you use it anywhere else, it is going to be the updated value. For example, here it would depend on what value you are going to get over here is like 5 or 6, whether you have used pre or post, but later wherever you see A, right, that is going to have the updated value. Same thing applies over here, that here the value might be different, but the condition check is happening somewhere else. So that's why you'll always get the updated value in condition check. Okay, I'll show you one interesting way of writing ifs. People write it. So okay, so this is like writing it. Okay, let me do one thing. Let me print the I. So this I is like a normal variable. You can access it inside the loop. Use string concatenation to print it. Integer to string conversion automatic happens. Right, so we are printing 1 to 10. No problem, right? You can even let's say let me not write this updation. Okay, so this updation part is not compulsory. I'll come to that part. Okay, how much time this loop would run? Or what do you think? How many times this loop is going to run? What are the values? Just tell me that range. It's not infinite loop. It's not going to run for 5 times. I don't have an updation. Take it carefully look. There is no updation that is happening. Updation is blank. That means I'm not doing anything in updation. It is still going to run for 10 times, 1 to 10. See what is happening. So firstly, I value is 1. Okay. See, it is the loop is running 10 times. The value that we are printing is different. Okay, that also clarifies that how it is working. See, so firstly we checked 1. What is the condition that check that happened over here? So 1 less than 10. Right now we got the value here is 1. So 1 less than 10. Now that condition is true. We entered inside it. Now we are printing hello world, but I value we have increased it. So we are printing 2. So I value that we are seeing over here is 2. Okay. Next iteration, I value is 2. We check 2 less than 10, which is true, but we increased it after the condition. It became 3. So we print 3. Okay. So when we'll check 10 less than 10, we'll increase it to 11. Inside loop will print hello world 11. Okay. And next time when we'll go over there, we'll check 11 less than 10. So that time it will become false and will break the loop. It is still running the loop in 10 times, that is 2 to 11, but inside the loop, there is a difference. Okay. There is a difference, but what if I write it in this way? How many times this is going to run? This is going to run for 9 times. This is not going to run for 10 times. This is going to run for 9 times. Why? Here, because the updation is happening first. So we are checking 2 less than 10, 3 less than 10. Firstly, we are updating it. So the first condition check that is happening is not 1 less than 10. It is 2 less than 10. Okay. And that, so first is 2, then 3, then 4, and so on. And finally, we'll check 10 less than 10. And thereafter it will become 11. So 11 less than 10, it will terminate. It is running for 2 to 10, which is 9 times. Okay, and there it was running for 10 times. The value inside the loop might be different, but the number of times it was running was still 10. Okay, understood? How you can like how that can be pre and post can change if you use it in condition. I'll write all the 3 ways. I'll actually copy it. So you can have all the 3 ways. So this is like the normal loop. This is like the same loop using post increment, but I've written the post increment in condition. Okay. And here, this is also the same loop. But here I've written it in pre-increment. So this runs for, let me write it, runs for values 1 to 10. Okay. This also runs for 1 to 10. Okay, condition check. I'm writing what's the condition check that is happening. Okay. This runs for 2 to 10. So this runs for 9 times. Others are running for 10 times. Okay. Understood? So see, this is very complicated. Like there is like a lot of things that can be tricked around. A lot of things. So programming is like I tell it, right? It's like a magic. You have given the tools and you can play around with something. You can create something new, something complicated to understand, something easy to understand. Okay. Okay. Understood this part? Shall we proceed? Okay. So now let me cover like the scope of this variable. Let's come back to scope, right? So I was talking about a small thing known as scope when I mentioned about the variable naming rules. Right? So I told you something about that the scope of variables. I'll come to optional loops. I'll come to that part just in a while. Okay. So in case of scope, so I told you that a scope of a variable is nothing but a pair of curly bracket. Okay. So a pair of curly bracket is the scope of a particular variable. So for example, let's say we have a if else condition, right? Very simple if else condition. Let's take this one for example. Okay. So this is a scope. Now, if inside this scope I create a variable, let's say int x is equals to 10. Okay. If I create it this way, or x is equals to let's say 100. Okay. So where can I use it? I can only use it until this scope ends. Right. Once the scope ends, I cannot use this variable. So if I write something like after this system dot out dot println x, this is going to give me error that this variable cannot be used because this scope is limited to this pair of curly bracket, right? Cannot find symbol. Okay. Now this is valid throughout any such scope. Okay. So you write it over here. So if you declare any variables within the scope, you're only allowed to use it. It is true in case of ifs. It is true in case of normal block scopes. That I give you example like normal pair of curly bracket, not a part of a for a for, like just like a curly bracket, right? So this is known as block scope. Okay, just a block scope. That is known as if scope, and this is a for scope. Scope of the for loop, right? This is also a block scope. So all of them are basically block scope. Block scope is a general term. This is like block scope of a for loop. Now here we have created, let's say this one, very simple loop, which is running for 10 times. Now this I variable that we have created over here, this cannot be used outside the loop. This scope is restricted to the loop. So if you try to use it outside the loop, it is going to give you error that it cannot find this symbol. Okay. So you cannot find this symbol. So the I or the variable that you declare over here, can we declare multiple variables? Yes, you can. So if you want to declare multiple variables, you can write int I equals to 1, comma int j is equals to 2. Until you hit the semicolon, that part you can create it as a declaration. Okay. Now you cannot declare multiple variables of different data types, but of same data type, yes, you can. I equals to 1, j equals to 2, k equals to 3. If you want to do multiple declarations, that also you can do. Can we write nested like logical expressions over here? If I is less than 10, j less than equals to 5, and let's say k less than equals to 5. Okay. Achha. If you want to have multiple updations, that also you can do. But okay, now multiple updations for that, this is like you cannot separate them by comma. Okay. So I guess that doesn't work. Does it work? I don't think that works. So this doesn't work. You can update it in the body. I'll come to that part, how you can update it. Okay. Okay, so you can change these values inside the value here as well. But I guess we can take it. If you feel, let's check, let's validate. I'm not sure if this comma thing works. It used to work in C++, but let's check over here. Comma thing works. Does it work? Does it not? Okay, it works. It doesn't throw any error, so it works. Okay. So this comma separated updation is also work. Right? So see, now we are getting I equals to 1, I equals to 2, I equals to 3. Okay. So how is this working is, see, we did multiple assignments, we check the condition. Now we have used and, right? So what's and checks true, true, true. All of them has to be true. You can use or, any combination of and or. If we want to create a loop like that, that also you can do. Okay. You have multiple updations, you can do it over here. You can do it in the body as well. That's also fine. Okay, I'll come to the part where you can do updations in body or play around with this loop, how you can create this loops. Okay, so okay, now this is like basically a multiple iterator loop where you have multiple iterators. We call these variables as iterators. Now you cannot access any one of them outside it, right? Neither you can access I, nor you can access j, nor you can access k. Okay, so these variables are just part of the loop, right? Anything if you declare within, even like if you created inside this loop, like int s is equals to, let's say 20 or 100. So you cannot access this S outside as well. So this scope is limited everything to this block. Okay. No, public and private are completely different. They are like not, that's not for scoping. Public private is like completely different thing. Okay, that is therefore inheritance, not for scoping. Scoping is just right, that we are using, right? Okay. Okay, understood this part. Keep the loop variables in simple words. Even if you have multiple variables, whatever you create inside loops, those variables are just part of loops. You cannot use them outside. You're going to get errors that it cannot, these symbols cannot be found. Okay, so this is not allowed. You can use them. Okay, let me write it over here and add a comment. This would give you error. Cannot find symbol. Okay. Okay. Did I erase the easy one? Okay. So this is what scoping of variable is in the loop. So the variables that you declare inside the loop are only part of loops. You cannot use them outside. You cannot consume them outside. Okay. Now there is, so one thing I told you in the beginning of loop that you can need to write these 4 parts: initialization, condition, updation, body, all these 4 parts. So actually all these 4 parts are not mandatory to write. You can skip any one of these parts, and whatever parts you can skip, according to that, the loop is going to work. So for example, let's say we want to write I is equals to 1, I is less than equals to 10. We don't write the updation altogether. Okay, we just write system.out.println. What is going to happen? And let's say we print hello, or let's say we just print I. Okay. So this condition is always true since the I value is not changing. So you'll see that this is printing 1, this is continuously printing 1, it is not stopping. Right? It is not stopping. My system would hang sometime, right? And then it would stop. Otherwise, it will keep on printing 1. Right? So it printed 1, lot of 1s until we forcefully stopped it. Right? In order to break this forcefully, you can use Control C, that breaks it. If you're on Mac, there also Control C works. Okay. Most of the compilers would be Control C, and few compilers it might be Command C as well. Okay, can we skip any 2? Maybe yes. Skip any 2 means yeah. If so we can skip the updation, that's fine, right? Can we move it to somewhere else? You can actually move this updation to the body as well. Now this is a valid loop which is running for 10 times. Okay, so this is a valid loop which is running for 10 times. We see 1 to 10, right? We just move the updation from here to body. Now it is it working in the same cycle? See, the cycle of this is fixed: initialization, condition, then body, then updation. Now it matters how you are using it inside the body, how you have written it, right? So just run it in that order. So firstly we do initialization, I is equals to 1. Okay, then we check the condition, 1 is less than 10. That's true, right? Then we go to the body, we print 1. Okay, that is fine. And then we change, increase I by 1, so I becomes 2. We change I to 2. We go to updation, there is nothing in updation to do. So we go to the condition, we check the condition 2 less than 10, this is true. Okay, so we check the condition, we again come back to the body, we run, we print 1, we print 2, and then we change it to 3. Okay, same thing that we were doing, we are doing it over here as well. Just that we are like we have moved the updation to the body. It is working in the same way, right? Now, okay, if we don't have this, this is definitely a infinite loop. Can we move the initialization to somewhere else? Yes, we can move the initialization to outside of the loop as well. So you can have a variable that is already present and you can use that as the iterator of the loop. You don't need to create a new variable. So for example, this loop is exactly going to run in the same way that the like this loop was running. Okay. So we have just created the I variable outside. Now, what is the advantage of doing so? Why will we ever create I variable outside? So if let's say after the loop, you want to use this variable, right? So you can use it like this. So you can print it. Now, this is not going to give you error like the earlier you were getting the error, cannot find symbol. No, you're not going to get error. So you're getting a value 11, which is coming from this. Okay, let me print this like this after loop. Okay, so this is going giving you the value that is after loop, and the statement that I told you, right? It actually runs for, it actually is checking 11 less than 10, and then it terminates the condition when it is becoming false, right? When the condition became false, the value of I was 11. So that's why after the loop, you are going to see the value of I as 11. Okay, but you can only access it if the variable is a not a like loop variable created local to the loop. It is like a variable that is created outside the loop. Okay, understood? Acha. We cannot skip this semicolons, they have to be there. So anything between the first bracket, first semicolon is initialization, anything between these two semicolon is condition, anything between this semicolon and the last bracket is updation. Okay. So you cannot skip this semicolon. So can we skip the condition? Yes, you can in fact skip the condition as well. Now, what will this be? So if you skip the condition, by default, it's always true. So this loop is going to run forever. Okay, so it is selling unreachable statement. Let me comment out this. So because this loop is never ending, right? Java knows this. So it keep on increasing it, it keep on printing it, but this loop never ends. Okay. Okay. So this loop never ends. So it will keep on continuously running till infinity. Okay. So the this loop is not ending. The loop can only end if the condition becomes false. Okay. So anything, so by default, if you don't write the condition, that's true. So you should always skip, avoid writing infinite loop. So you should always have conditions in your loops, right? You should have valid updations. So if you skip updation, so if you skip updation, this also becomes infinite loop, right? Skipping updation also makes it infinite. Skipping condition also makes it infinite, right? So right now it is like a loop that prints 1. Okay, since I value is not increasing and so on. Understood? So basically, if all the parts in the if are optional, you can we put condition in the body of loop? No, condition cannot be moved to the body, right? There is one way to actually do it, but not in like this ICView cycle. That is a different way, which is using flow control. I think I'll come to that flow control part. We'll cover that today itself. So yeah, that we can cover it. Okay. Yes. So let me give you a dinner break. So quickly come back from dinner. We can continue from here. Okay, there is a lot of things in loops that's there. I guess 15 minutes should be fine to have your dinner. Quickly come back from dinner. Okay. Hello everyone. Welcome back. Okay, I hope you all had your dinner. You got time to cook your Maggies and you had some good Maggie. Is there anyone who is there in final year of college or a college student? Right. So how do you have your dinner? Right? Is 15 minutes sufficient for you all, or you come to class after having your dinner? Because I know it's called for college students, it's become a little bit problematic. The timings takes me 2 minutes. How like your talent is to eat fast. Okay. Okay. I used to eat very slowly after the class. So after the class, is the mess is open, right? Now that's a big question. Is the mess open? Okay, we cook. Okay, then that makes sense, right? Because the mess timings are generally from 8 to 10 or 8:30 to 10:30. Help of roommate. Yes, it's good to have a roommate like that, which brings food for you. Okay. Uh, Yeah, 8 to 8:30, that's like the best time. If the mess opens in that time, then you can have your dinner, come to the class. Just that you don't need to sleep in the session. Okay, until that does not happen, I'm okay with everything. Okay. So let's wait. Can we start a little bit early? Actually, I go to office regularly, right? And that's also a little bit uh too early for me to come back, start the class at 8:30 looks fine, and it's like also comfortable for other people who are working, right? Because the people who are working, they generally come from office to 6:30. But moonlighting, no, it's not moonlighting. I have proper permissions to teach, right? So Microsoft is like very much open about it. Yes, you would generally see all the YouTubers or something. They openly see, right? They openly work or have their YouTube channel. They openly have their own side hustles. So Microsoft has no problem if you have side hustles. Okay. So actually, like the actual contract that you have for any company always says that you are only required to work for 8 hours for the company. What you do in the remaining 16 hours is none of the business of the company. That's complete your personal time. You want to do something you like, you want to do teach, you want to create your own startup, whatever you want to work on, that's completely up to you. But there are few companies which like don't like people growing into other domains or learning something or building something of their own. So create such rules that you can't moonlight or do things like that. Or so okay. Uh, okay. Hello, let's continue. So we learned about for loop, right? So this is like the basic loop that we have, which is like a for loop where we create initialization, condition, updation. Now this is flexible, right? You don't need to write all of them in a single line. You can move the initialization to outside of the loop. You can skip the condition, you can skip the updation. Now depending on whatever you have written, the loop will, it might become an infinite loop. It might work still in the same way. That you can play around with this loop to create it in a different way, and that's also completely fine. Okay. Now whatever logic that you have, that will always go to the body, right, that you want to run again and again, so that will always go to the body of the loop. Okay, let me cover the syntax of all the loops first, and then I'll go to solving questions. Okay, so I'll take half an hour to complete the remaining ones. The remaining ones are also similar. So there are two other ways to write loops. Okay. So like most of the time we write for loops like we create for loops like this. Now it becomes a little bit not very clean to look at, not very clean to read at. So someone thought of, okay, if like we just need the condition to run the loop, then why do we have all this part compulsory as the loop, right? So what someone did was someone created a while loop where the initialization is just outside the loop. We have a while which has a condition, and then we have a while which is a condition, and then we have a body of the loop. Or if you have any updation, that would also go to the body of the loop. So if you have any updation, that would also go to the body of the loop. Okay. So initialization, we have a condition, and then we have body of the loop. If you have any kind of updation, that would also be a part of the body of the loop. Okay. Next, okay. How while loop is different in terms of from for loop. So while loop also works in the same way as the for loop. Okay, while loop also runs in the same way as the for loop. For loop does. Just a second. Okay. So we have like sorry. So we have initialization outside. We have the condition that is only part of the while brackets, and we don't have any updation like initialization in this. Now this condition part is compulsory in case of while loop, which was not in case of for loop. So in for loop, if you skip this, it was running as an infinite loop. But in case of while loop, if you skip this, so that's going to throw you error. Okay, let me try to firstly do the same thing that we did earlier, like while I equals to 1, I less than equals to 10, and we just print hello world, or we just print I, print ln I. Okay, and we can do I plus plus. So this is the same thing for loop that we wrote over here. The same thing we are writing over here. It just it using file. How to put multiple comments? Just select everything, control slash. Okay, select everything, control slash, and control slash to uncomment. Okay. Okay. Do we need to initialize every variable will declare? No, you don't need to initialize it, but you don't need to always give it values. But if you are like, okay, so there is, okay, let me show you what's the issue that you will go to. That's there. Okay, so I'll come to that question. Okay, let's first complete this one. So it's also running in the same way. Here there is only one constant. You cannot skip this condition. If you skip this condition, it's not going to be an infinite loop. It is going to throw you error that this loop does not work, right? Illegal startup expression. Okay. So this is something which you need to keep in mind. So in case of for, if you skip the condition, that's an infinite loop. But in case of while, if you skip the condition, that's a error. That's not an infinite loop. Okay. Understood this? Okay. Now, remaining part remains same. The order in which for and while loop runs is initialization, condition, body, updation. Updation is part of body. So wherever it is there in body, it would be in the or like order in which the body is running. Okay, talk about. Okay. So yeah, that's what I was telling Gopi. So you can select everything and control slash. Single line comment that would comment everything. Okay, single line comment that would comment everything is control and then slash. Okay. No, we can initialize I in the while loop, but we need some iterator, right? We need some iterator. What are the default values for data types? So I guess we have covered that default values for data types for number set integer, for decimal number set double. Okay. Okay. So we cannot initialize it in any way over here. You can do some initialization if you want to create some variable over here, that you can do. But the iterator that you will be using for while loop, that has to be initialized outside the loop, right? So if you like, if you create a condition where you don't need a iterator, for example, if you just write while true or something, so in this you don't need a iterator, right? So then you don't need that iterator or anything. Okay. Or if you have just a Boolean value, you can just write that Boolean value inside instead of this condition. That would also work, right? Any default Boolean value would also work, right? So anything that you have, like for example, if you have a Boolean b is equals to 2 or false, so that also you can use over here. If the b is coming from a particular expression like 5 is greater than 10 or something like that, so that also you can use. Now, when you give it a value, for example, let's say this Boolean b, okay, let's say instead of doing this, I just run this. Okay. So I have just changed the condition and I have C. So now it is false, so it is not doing anything. But let me make this condition true. Okay. So if I put a true in place of this, it is going to become an infinite loop. Okay. So what's the way to create an infinite while loop? You can simply put a true or a condition that is evaluating to true always, or a Boolean true value, anything, right? If you put a true, that is this will make it infinite. Okay. So while can still be made infinite, but here you have to like, you cannot skip the condition to make it infinite. You can put a true value always at something that is always true. For example, true. True is always true. There is no way this like this condition will be ever become false, and it will always run the loop, right? So you can make a always true condition and run it. That will create an infinite loop. But here, like if you skip this condition, that is not going to be infinite. That is going to be error. Okay. Understood? Boolean can be used in for loop. So see, anything, anywhere you are using relational or logical expression. Okay. Anywhere you are using relational or logical expression, that is nothing but a Boolean value. Okay, so you can use Boolean instead of any relational logical expression. That is valid for loops or if conditions, for anything that you'll see going forward. Wherever you have used a relational logical expression, the result is true false. So that you can use anywhere. Okay, it is not restricted. You can not use Boolean. You can use Boolean anywhere wherever you have used relational logical expression. Okay. Understood. While loop also runs the same ICView cycle. Here, like there is no updation explicitly, so we say it as initialization condition body. Okay, initialization condition body. If there is any updation, that is a part of body. Okay, so the updation is part of body. There is no explicit updation statement over here. If you don't have any updation, so it is like going to work check the condition. Right now, the condition is always true, so this is also infinitely, where you are going to print one simply. If you are not updating it, the condition is always true. You are going to simply print one. Okay. Okay. So this is what while loop is, just a better way of writing the for loop, where we created so many optional things. It does not look cleaner, where you have semicolons and this semicolons lying, which is not doing anything. Instead, a while loop looks cleaner, where you don't have such those additional hanging semicolons, and you have like the compulsory condition that you have to provide, so that you don't by mistakenly make it a infinite loop, right? But you can still make a infinite loop out of while by passing a condition that is always true. I can do it in multiple ways. Yeah. So the last kind of loop is do while loop. Now this is little bit different, and this is a lot of different. So the syntax of do while loop looks something like this. If you have any initialization, that will go outside of the loop. If you have body, so that is coming first, body of loop. Okay, for each loop is there. Sorry, that is that we are not going to learn for now. Okay, for now, try to use this basic loops. Okay, firstly get comfortable with these loops, and then you can use the for each loop, all those things. Okay. But for iterators, like it's you can always need to use this loops, right? You cannot use for each for it this that is only there for arrays or strings or something like that, or reference types. Okay, now you have while and you have condition. Okay, now the cycle of do while loop is actually different. The do while loop runs in a different cycle, so that is ICView cycle, right? So this runs in, I'll say I initialization condition body condition body. So that is the cycle of while loop. Okay, where you have condition body, and this keeps on repeating until the condition becomes false. Here the cycle is little bit different, where you run the initialization. You firstly run the body and then check the condition. Okay, firstly run the body, then check the condition. Run the body, then check the condition. Okay. Now, whenever the condition becomes false, it terminates. But look at the difference over here. So firstly, we are running the body. We are not even checking the condition before running the body. So even if the condition is false, we'll end up running the while loop, do while loop at least once, right? So the updation, if there is any updation, that has to be part of this body itself. So there is no explicit updation. If there is any updation, that has to be the part of body. Okay, same like here. So there is no explicit updation. If there is any updation, that is always a part of body. Here also, if there is any updation, that is a part of body. Okay, so let me do the same thing. Print 1 to 10 from I equals to 1. Do system dot out dot println I, and then we can increase I updation. We can do it inside body, and then finally the condition while I is less than equals to 10. Okay. Now let me run this. So this would also work in the same way. It would print 1 to 10. Okay. See, 1 to 10, no difference, right? If I remove this updation, it is going to become an infinite loop where we are going to print. Where we are going to just print 1. We are not going to like, we're just going to keep on printing 1. We are not going to update it. So it's not going to end automatically. It just keeps on printing 1. Okay. Now this is 2 while loop. Okay. Now we increase it. Now this is like works as the normal loop. Now what's the difference? What's the difference between a do while loop, and for loop? So for while was basically created just to like an enhancement to the for loops that we were writing. So we were writing loops like this, which does not look very good. So we created while loop, which looks cleaner, which looks better than the for loops. Okay. Now in case of this do while loops, what we are doing is we are running the body first. Now here there is a little bit different of how it works. Okay, let me show you all the three loops once. So let me just copy this. Okay, let me just show you the how these loops would behave. Okay, so let's say let me go to the for loop first. Okay, that was the first one that we did. So let's scroll up. Okay, so this is our for loop. Okay, so now here let's look at the for loop. Okay, in case of for loop, let's say if I write a condition that is false, right? So for example, I write I greater than equals to 10. So 1 greater than equals to 10, the initial condition itself is false. The first time the condition check is going to happen, it is going to result in false. So see, it does not print anything, nothing, right? No output. If the condition is initially false, the for loop does not print anything. Okay, let's check for the while loop. So while loop, what if I make this condition as false? If this is greater, if I run this, if the condition is false, the while loop also does not print anything. See, so it also doesn't print anything if the initial condition is false. If for any way, like if the initial condition is false, it also would not print anything. Now, what about do while loop? So in case of do while loop, even if the initial condition is false, the loop runs for actually once. Okay, loop will run for actually at least one time. So you're seeing one as output. Right? Why it is running for actually even one iteration? Because here we run the body first and then check the condition. Okay, so firstly we check ran the body. So we ran the body. We even did the updation as well. So when we check the condition was 2 greater than equals to 10, not 1 greater than equals to 10. Okay, so if after running once, if the condition became true, then it would even run it further, right? So the initial check, initially first the body runs and then the condition check happens. Okay, so here it is different than how it runs. So even if the initial condition is false, the do while loop ends up running at least once, even if the condition is false. So that's why we prefer using for and while loop instead of do while loop. Okay. Now, what's the usage of it? So it is used in situations like where you don't want to check the condition first. You have a situation where you want the initial condition to be true. Okay, there is one question in the portal as well where you want to take inputs of even numbers until the user gives a odd number as input. Okay, so that question is a very good example of solving using do while loop. Okay. So there is one question that is commonly asked: what is entry and exit control loop? Entry control loop. What is entry control loop? Okay, and what is exit control loop? So entry control loop is like, I'll come to that question, how to take multiple inputs. Okay. So entry control loops is basically, sorry, there was one more question that so entry control loops are loops that check. So we check the condition before entering the loop. Okay, and here we check the condition after the loop. Okay, so it's like telling that you go to a restaurant, you firstly you need to show some proof that you can pay the bill, then only they allow you to enter into the restaurant and you dine in. Otherwise they don't allow. That's like entry control. The other way is like they don't check the condition that whether you can pay for the bill or not. They allow you to enter to have dinner and then they check whether you can pay the bill or not, right? And if you cannot, then that's a very big mess, right? Okay, so it's like exit control loop. The condition check is happening at the exit of the loop. The condition check is happening at the entry of the loop, right? Okay, now entry control loop will not even run for once if the initial condition is false. Exit control loop will end up running for at least once if the initial condition is false. Okay, understood? Clear? Then they keep you in restaurant forever. I always get that feeling कि ये failed UPI कभी restaurant में बर्तन धुलवाएगा. Yeah, that's why I always take cards while going to restaurants specifically. Okay, understood this concept. Entry, exit, control loop, for while and do while loop. All the three loops. Is it clear? Any doubts on the basics? There was one question that I told I'll take up, then I forgot it. How to take input of boolean from user, that is xc.nextInt, right? So that's you can use xc.nextInt. Default values for uninitialized variables. Now there is a now coming to that question. Yes, that was the question. So see, now there is, if you don't have any initialization, right? So if you don't want to create a variable where you don't want to give it any value, that's fine. Then give the value later and you can print it. Okay, so if you give the value later and you print it, that's fine. Okay, this will not give you any problem and you are printing it, that is fine. But if you don't give it any value and you try to print it, Java will actually throw you error. Now what's the error that it will throw you? That this might not have been initialized. So you cannot print uninitialized variables, okay, until you give them value. Okay, so if you don't give them value, it is going to give you error that this variable might not have been initialized. It does not have any default value that is stored in variables. So you get a error right away. Okay. Now let me show you one more thing. Instead, let's say you can we write something like this? If let's say 5 is less than or 5 is greater than 10, and we do something like this, a is equals to 10. Okay. Or let's write a condition that is true, right? We have written 5 less than 10. This condition is true, right? We know this condition is true. Let's try to run this. Okay. Now you're seeing this is giving you the result that 10 is printing, right? Because this condition was true and you're getting this result. Fine. Let me do one thing. Let's take b is equals to sc.nextInt. And I write it as b less than 10. Okay. Well, let me give it a value. Okay, let me give it b is equals to 5. Same condition, I've just put the value in b variable and I'm checking the same condition, 5 less than 10, and I'm giving the value of a. Now you see that it is giving us the error again. So what is happening over here? Why it is behaving so different in so different situations put together? So see, let me sum up first. So firstly, if you don't have any value, if you have not given any value and you run this, it is going to give you error that this cannot be printed because this is not initialized. Okay, that's fine. Anything that's not initialized, that cannot be printed. Okay. So now let's see this one. So what if I just give it some value after declaring it and then I print it? Will it work? Yes, it will actually work. If you print it after giving it some value, that works. Okay. Acha. What if I don't give it a value like this? I give it value in some condition. Okay. So this condition would work if this condition is always true. If this is a always true condition, we call it as a truthy condition, which is always true. This condition is always true, no matter it is not going to vary, right? This condition is always true. So if you have done an initialization inside a truthy condition, we call it as a truthy condition, which is always true. Okay. If you ever hear this truthy, so this is no TRE. Okay. So truthy condition. So what is a truthy condition? A condition that is always true. Okay. What is a falsy condition? A condition that is always false. So if you have put a like initialization inside a truthy condition, it is going to work. But if you have put a initialization inside such a condition that needs to be checked, right? That depends on some values, or this needs to be checked. This might be true, might be false. This depends on b value or something. Then it would still give you the error, because if this condition is false, then this initialization never happens. And you are still trying to print a. So it is going to give you are trying to give print a, which is uninitialized. Okay. So depending on how you have like created a and used it later in your code, depending on that, it is what if b is final? Now if we make b as final, now this is interesting, because this becomes as a constant value. Now this is a always true condition. If b is final, b is constant. So it will still work in the same way like if we are using constants. So final values are just like constants. Okay. So it is similar to writing constants. So final values work differently. Like when you have finals, so it just replaces every occurrence of that with the value directly. Okay, but when you have variables, it looks for the value, whatever is there at that point of time, and then uses it. So the read happens from memory in case of variable, but in case of final, it updates them in the compile time itself. So it's just similar to writing this, which is fine. Okay. Now, what if the last question, what if this A was final? So in case of final variables, do we have any default values? So let's try to check it. So for final variables also, we don't have any default value in Java. In other languages, the final variables have default value like 0. I guess in C++, the default value of final or const variables are 0. Here we don't have that. So you have to give the value there. Can we give it later? Now you cannot even give a value later to this variable because it was declared as final. Now this is an interesting problem. If you declare a variable as final, you cannot give it a value later as well because this is a constant declared as final, right? Actually, it works. Okay, this works. So the initialization is actually allowed later. Okay, so this works, I guess. Okay, so you can do this, break it into multiple steps. So this works. But you can do it only once. You cannot do it multiple times. If you do this, this would definitely fail. Okay, now this is like a design problem in Java. So C++ one was better than this actually. So for C++, for const variables needs to be assigned values while declaring. You cannot give values later. So this defeats the purpose of const. Stack and heap, I'll explain that part. Don't worry, that part will cover whenever we'll start with arrays. I'll cover that part because I'll cover that in very detail. Don't worry, that's like going to be there most probably Monday. Okay, clear? Understood this part? When you see this error, okay. So any initialization, if you create variables and you don't try to put it value, if you try to do it inside conditions, now if it is a condition that might be true, false, then you would see error that this variable is not initialized and you cannot print that variable. Okay, simple as that. Okay, no doubts. Shall we proceed? Well, I'll give you one simple hint and that will solve you all of your questions that you have in the portal. Okay. Okay. So B less than part. Okay. So this part C. So let's say we created a variable. Okay. And we created this condition and then we are printing it. Now tell me what the value of this condition can be. This values of this condition can be true or false. Now it is not concretely true always, right? It depends on the value of B. So it is not a truthy condition. Okay. So what is a truthy condition? Condition that is always true. So this is not a truthy condition. It depends on the value of B. So we'll get an error that this is an initial. This might be uninitialized. So we will see error. Okay. You can use a ternary operator. That's fine. You can use a ternary operator as well. But ternary you need to give a else value as well, right? But B is 5. B is 5, but it's not always, right? So B is a variable. Now variable and final, the constant values differ. Variable means that what does the term variable mean? That its value can vary. It can change. Right now we have given 5, but what Java doesn't know now. If we have written some logic between here to here, which changes B value to B++ or B equals to 10. Why Java will do so much things like just to do this, that it will check that we have not changed its value and we are still checking with B value 5. So that check happens in the runtime. Java cannot throw it in the compile time at what is the condition that's going to run. So that is the runtime, right? Compile time mein pata nahi chalega, right? So, but if you have 5 over here, so Java knows in the compile time itself that this is a true condition. No matter whatever you do, this is always going to be true and this condition is going to run, right? And if you make it final, that also makes this condition always true. Because if you make it as final, that also makes it as condition always true. That's a good analogy, Nitesh. Yes. Okay. Okay. Here, but the check happens at the runtime, right? Even if it is no, if it is 5, the check does not happen runtime. See, if it is 5, Java will know in the compile time itself. It is true. Okay. But if it is variable, Java will not know. If it is constant, then it will know in compile time. So let me clear this out. Keep what Java knows in compile time. So for constant, so this comparison it will know in the compile time. And for example, if b is constant, right? Any constant, or let's say any constant is less than whatever condition you have written, right? Any constant, these two things it will know in compile time. So then it will not give you error. But if it is any variable, okay, this it will know it in runtime. This is definitely going to be error. Okay. So okay. What's the difference between compile time and runtime? Compile time is the phase when your code gets converted to 0, 1. Okay. So two steps, right? I told you code gets converted to 0, 1, and then machine understands that 0, 1 and it runs that 0, 1 instruction. So the conversion is compilation where we do it. So Java has a two-step compilation, compiles to 0 byte code and then interpreter interprets it to final binary. Runtime is when the code actually executes, machine actually runs the logic and gives the result that this is the result. Okay. So two step, right? एक conversion करना. One is the conversion when you are converting into 0 and 1, when you are converting English to French, English to binary, right? And then you are running that instruction, right? So that is runtime. Okay. In a non-truthy condition, you always have to give it some initial default value so that when you print it, you don't see the error. Okay. And this is again some kind of input output question that you might get at what's the error in this or if it is working fine. Okay. So in Java, there is a lot of ways to create errors. Okay. Actually, it is more than other programming languages. Okay. So, okay. Now the last part, and this is like hint to all the questions that there in portal. Or if you are smart, you will be able to get the answers of all the questions using this. Otherwise, we need to solve it, right? Okay. Or you will become smart over time. We can put it in that way. Yeah. Let's say we have a number. Okay. And I give you a simple problem that just tell me the last digit of the number. How can you tell me the last digit of the number? Okay. So the last digit of the number is just by percentage 10, right? If you divide it by, if you do it a percentage 10, you are going to get the last digit of number. Yes. Okay, we got 4. Okay. Okay. If we update the value of a in some value and then we finalize, no, we cannot do it, right? If you update it, you cannot finalize that. So you cannot, if you have to declare a variable as final, you have to declare it initially. You cannot later convert it into final. Is there any way? I don't know if there is any way to convert later into final. Yeah. Okay. So this is how we can get the last digit, right? What if I tell you to remove the last digit? How can you do that? How can you remove the last digit of a number? Divide by 10, right? Yes. Okay. So this adds, keeps you the last digit. This removes the last digit. If a equals to 10, finally equals to 10. No, that doesn't. Does that work? Let's check. No, that's interesting. I don't think that would work if you write a like a and you can later write finally is equals to 10. Does this work? This is error, I guess. See, error. It is expecting a data type, right? So we want to create a variable as final. It has to be done in the declaration phase. You cannot later change it. Okay. Tell me, understood this part, these two things. How we can get the last digit, how we can get the remove the last digit. Okay. Now, this is the entire logic of any number manipulation in Java. Okay. Okay. How does this? How is this the entire logic of number manipulation? Look at this. So let's say I want to print all the simple question, print all the digits of a number. Okay. Okay. Now Okay, so print all the digits of a number. Now what you can do is, so you can check for a number, right, until it is not equal to 0. So if n is not equal to 0, we can keep on checking that number. Let's take this n as some number. Let's say n is equal to 1, 2, 1, 8, 3, 4. Okay. Now, what is the last digit of this number? What is the last digit? N percentage 10. Is this going to give me the last digit of the number? Yes. If I do system.out.println, what would I get? I would get the last digit, which is 4. Okay. So the first time this loop runs, I get the last digit as 4. Next time this loop runs, I get the last digit as 4. Next time this loop runs, I get 4, 4, 4. And this is an infinite loop. It never ends because n is not equal to 0 and keeps on running this. Acha. Can we change the last digit to something else? Can you use something like this? If we change the number itself, if we just change the number to n is equal to n divided by 10, now see what is happening. So for the first iteration, when we enter inside this, the number was 1834. Okay, this was our number 1834. Now what we did, we got the last digit, we printed it, so it will print 4. We changed the number by removing the last digit. What does this do? This removes the last digit. So this changed it to 183. Now again, we checked, is n not equal to 0? Yes, it is. We again went and said, now we are finding out the last digit of number 183. What is the last digit of it? 3. So we get 3. Right. Next, we again remove this. So this becomes 18. Next, we again find out like the last digit, which is 8. Which is 8. So we print 8, change it to 1. Okay. Now the number is 1, which is still not 0. We find out the last digit, which is 1. We print 1. And then we divide it by 10. So 1 divided by 10 is 0. So we finally check, is it not equal to 0? No, it is 0. So we don't have any more digits to print. So finally we get these are the digits of the number. Okay, let me run it once. Okay, 4381. Okay. Let's now, if this has trailing zeros, that is not a problem, right? If it has trailing zeros, you are going to see 0. It cannot have leading zeros. If there are leading zeros, those will get omitted, right? If there are leading zeros, that will not print. Okay, and leading zeros mean something else. If you have leading zero, that is not even a decimal number, that is an octal number. Okay, so any number that starts with 0 is not a decimal number, that is an octal number. Now that's completely different. Okay, let's not go into that. Leading zeros, trailing zeros are fine. 1020, it's not going to be a problem. See, run it step by step. So it is going to be 1020, then 102, 10, 1. None of them are 0, right? So it is going to work in any condition that you're in. Okay. So 0, firstly we got 0, then 2, then it was 10, right? 10 is also not equal to 0. And it was 1, 1 is not equal to 0. There is, you will not get inputs with numbers having leading zeros. Okay, that is like a completely different thing. You'll never get inputs with number having leading zero. So don't have to worry about that. Okay, that's not going to be there in any of the test case as well. So there might be trailing, but not leading. Okay. Achha. First, you tell me, did you get this part, how this is working? So we are finding out the last digit. We are printing that. We are removing the last digit, finding out the last digit, printing it. And now there are a few things to observe over here. Now, what's the final value of n? If I print the final value of n, it's going to become 0, because what we did was we updated that value in the loop. So for the final value of n became 0. Similar to like what's the final value of what's the last condition that you checked, right? So that's where the loop ends. So that is like the final value of. Now, if you have any operation that you want to compare, like something that you did into for the initial value, you want to do again some logic on the initial value, then you need to store it in some other variable like p or something, whatever you create, so that you can access that value. So if I want to print it, print the like number after this loop, then you need to store it in some other variable and you can use that. Okay, we call it as a temporary variable or something that is storing this value. Okay. Now, coming to the questions that you have. So all questions can be solved by this. So let me give you examples of this. Explain the solve number rotation with leading zeros. Now I'll come to the leading zeros wala part. I'll come to that. Okay. Number rotation wala question. Today will end with number rotation. I'll give you idea of how to solve it. Okay. Don't worry about it. Okay. I'll not leave you with questions today. I'll leave you with solutions that you can try. Okay. So now here, what's like, so this is, we understood that we can take out the last digits, we can do this. Now, before going to this, let me just tell you few things that we can do using loops. Okay. So print last digits of number. Let's say we, let me like, just tell me whether you will be able to solve these questions or not. Print even numbers from 1 to 100. Can you do this? Anyone having doubt on this? Find some sum of all numbers from 1 to 100. Find sum of even numbers from 1 to 100. Yes. Can you solve all this? Sum find कर सकते हैं. So let me do this one. Yes, someone let me do it. So I can find out sum. So see, we can take an initial sum which is 0. Okay. We can run a loop that will run from, let's say, our starting value is 2, we'll go to 100, right? First even number, and then we can increase it by 2, right? So I is equal to I plus 2. You can increase it by 2. Or you can alternatively write I equals to 1 to 100, and you can even check using a if condition. Yes, you can use the formula as well. That is also fine. I want to show it using this too. Okay. So you can do sum plus equal sum plus sum is equal to sum plus I. You print this. This prints the sum of the even numbers that you got, right? So whatever even numbers you got, that you can do. That if you run the loop from 1 to 100, you can even check using if condition inside the loop if this is true or not. I'll explain number rotation. Like just give me a little. Just give me a minute. Okay, I'm coming to that only. Okay. Okay. So see, what we did, I just started from 2. I just ran till 100, and then I increased it by 2. Right? I increased it by 2, and then we just found out all the sum. Like you can run a loop from 1 to 100. You can increase it by 1. You can write a if condition. That is also fine. Okay. Now this is how you can find out the sum of something. Now, like there is few questions that you can do using this. You can find out like there is one question. Yes. So you can try to do the Fibonacci series. Okay, try to, if there is a question that's already there, you can try this one. Or if it will, you will be able to find this question in the gym. If not, then we'll solve it tomorrow. We'll try to print this Fibonacci series. So this is a series of number which looks like this. So the series, every next number is nothing but the sum of previous. So the first two numbers are given 0 and 1. The next number is nothing but the sum of previous two. So 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21. And so on. Okay, so this is a Fibonacci series where you are given the first two digits, 0 and 1, and every next number is nothing but the sum of previous two digits, previous two numbers. Okay. Now, in this question, print all the digits. You will be asked variations of it, like print the sum of all digits. Can you do it? Of a number. Print even digits of a number. Print reverse of a number. Now this is interesting. This one also. Okay. Now, Asha, tell me these three. Will you all be able to do them now? Sum of digits, even digits. Yes. Anyone having doubts in these three questions? Okay. Now reverse of a number. Can you all find out the reverse of a number? Okay. Let's say if you found out the reverse of the number. Okay. Let's see this. So, So this would give us the reverse as 21, right? If you did it using this logic, so let me just write that thing. Don't need this. There is one question to check if the number is palindrome or not, which is nothing but just to check the reverse. Okay. So what you can do is you can take a number which is reverse and REV, which is equal to 0 initially. Let's take for simplicity this number. And what you can do is reverse is equal to reverse into 10 plus t. Does everyone understand how this works? Why this works and how this works? Yes. So basically what we are doing is, okay. See, what we are doing is if we have any number, right? So if you have any number, let's say you have, I give you two numbers, 94, and I give you a digit, let's say 3. Okay. And I ask you a simple question, can you add this 3 to the end of 94? So can you make this 943? So how can you do it? So the simplest way to do it is you multiply 94 by 10 and then you add 3. This is the only mathematical operation using which you can do it. Okay. So you multiply it by 10 and add 3. This is the only mathematical operation by using which you can add a digit to the end of a number, right? Okay, not literal addition. It's like adding concatenation, right? This is one way, or you can do it using strings as well, string then converted integer. That is the long route, right? But mathematically, you can do it in this way. Now, the same thing that we have used over here, we are getting the numbers digits from the reverse. So we are getting 7. So we are multiplied 7 by 10. And then, sorry, first we had 0. So 0 into 10 plus 7. So we have got the number as 7. Then we did 7 into 10 plus the digit that we got is 6. So it became 76. Then we did 76 into 10 and the digit that we got is 5. So it became 765. Okay. So on. So we got the numbers 765, 765 into 10 plus the digit that we got is 4. So 7654 and finally 7654 into 10 plus 1. We got 76541, okay, which is the number. Okay. Now, what if you have leading like trailing zeros at the end? What is going to happen in this situation? So you're going to actually, so if there are trailing zeros, you are actually going to lose them in the reverse if you run this. So the reverse is going to be like lost. So if you just have this, so that is going to get lost. Okay. Now, okay, how to swap 1 and 7? So first and the last digit. Okay, I'll come to that. Okay. You don't need strings always. You can do it using number manipulation as well. Okay, so this is one flaw in this approach. Now, if you want to preserve this, so there is few ways to do it. So what you can do is you can count the number of. Okay, can you count the number of trailing zeros? Can you do this? Count the number of digits. Okay, so this is one question. And can you do this? Count the number of trailing zeros. Okay, so let me show you this. Yeah, I'll not give you a direct answer. I want you all to try it, but I'll give you the ways on which you can think, right? So can you count the number of trailing zeros? So this is like the reverse logic. Okay, so let me remove this. Let's print count. Okay, so let's uncomment everything. And we have int count, which is initially 0. Okay. So what I am doing is every time I'm finding out the digit, I'm simply increasing the count by 1. So what this is doing is this is counting all the digits in the number. This is counting how many digits are present in the number. So it is saying there are 4 digits in the number. Now, how can we count the trailing zero? So if the digit that we are getting, okay, if the digit we are getting is 0, then we are fine. If the digit we are getting is we need to also understand flow control before it. Okay. Now coming to how we can solve this actual problem is by using flow control. Okay. Now what is flow control? Okay, flow control we did not study in loops. Okay, that was something. Do we have time? We have 8 minutes. Okay, so flow control can be done. Okay, so what is flow control in loops? So the loops works like once you enter the loop until the condition becomes false, it it keeps on running it, right? But there is a way to break the loop in between, which is known as flow control. Okay. And there are two statements that you can use to flow control is break and continue. Yes, it's break and continue. Okay. So what is this break and continue? So let me just write a simple loop. I is equals to 0, I equals to 1, I less than equals to 10, I plus plus. Okay. There is goto in Java. There is goto, but goto is like goto flow control. We don't use generally. So I'm skipping that. Okay. I guess goto is there, right? You can just validate it. Goto is there. Okay. So we don't need to do this. Okay. So this is like the normal loop that we run, right? Normal loop prints 1 to 10, no problem, nothing different. Let me comment this all once. Okay. Normal loop, nothing different, prints 1 to 10, right? Acha. What if I write something like if I is equals to 5? Okay, I can write if condition inside this, then we can break. What is going to happen? Now, if we write a break, what is going to happen? Firstly, it will check. If this condition is true, then it will what it will do is it will move the control directly out of the loop. Okay. So if we have like if this condition is false, we'll not run this break, right? So yeah, you can put it even brackets. That is also fine. But if there is like if this condition is false, we keep on running this. But once we hit this condition, it breaks the loop. That means we come out of the loop directly. Okay. So this is like how we can break the loop using a flow control. If a particular condition is satisfied, or if you ever encounter a break inside the loop ends then and there. Okay. Here we have a continue. What this does, continue. So continue basically skip everything that's there below this statement inside the loop and it directly moves to the updation. Okay. So if I run this, so what it does is it checks the condition. If it is true, it will continue directly to the updation. So now you'll see everything is printing except 5. So why 5 is not getting printed? Because so 1 was false, 2 was false, 3 was false, 4 was false. When it was 5, so it was true. So we did continue. So it went to directly updation. We did not print that. So it directly went to updation. So that's why we don't see that 5 getting printed. Okay, then we check the condition. Condition is false. Sorry, condition is true. So we come inside. Now it becomes 6. So that is false. So we print 6. Okay, so only 5 is not printed. But when we had break, it was actually ending the loop then and there. So we were not seeing anything from 5, 6, 7, 8, 9. All those outputs we are not seeing at all. Okay. Understood. Break and continue. What it is, what it does. Yes, it is used for breaking the loops. Okay. Continue just like skips anything that's there below it, moves to directly updation. Break exits the loop directly. Okay. It will skip 5. Yes, it will skip 5 if you have like whatever condition satisfies, right? So whatever condition satisfies, if you have anything below it, it will not run that part. It is like if as soon as it hits continue, it just goes to the updation part. Okay, so if I write a condition like if 5 is equals to 5 or is equals to 6. So now for 5 or 6, both of them it is true. So it is not going to print 5 or 6 and other values it is going to print. Work as not. So we are not seeing any 5 or 6. Okay. Understood? What is break? What is continue? What they do? So break ends the loop. Continue moves it to the next updation. Simple. Now, how can we use it? So, for example, let's take this particular question where I gave you to count the number of trailing zeros. Okay. So, if you just increase the count by 1, it is counting the entire number of digits. Okay. Okay. Now, can we do it in this way? Chalo, tell me this thing. If the digit is 0, okay, let's check this number. Okay, I'll give you a different number. If the digit is 0, increase the count by 1. Okay. And let me run this. So how many zeros are there? There are 3 zeros. Okay. So it is telling 3. Is it correct? Is this logic correct or there is some mistake in this? My question is to count the number of trailing zeros. Okay. So this does not count actually the trailing zeros. This counts all the zeros. So if there are zeros over here, these are not trailing zeros. These are just zeros. So it will end up counting them as well. Okay. So it is not actually counting trailing zeros. It is counting the okay. It is counting all the zeros that's present in the number. Okay. So what we can do, how we can just count the trailing zeros. So if the number is 0, then we count it. Otherwise, if the number is non-zero, that means from here, right? If the number was 0 till now, that will count it. We'll start it from the end. We got 0, 0, we kept on counting it. As soon as we get a number that is non-zero, we'll simply break. We'll come out of the loop, right? So now it will ensure that we'll just counted the trailing zeros. So we are getting 1, which is like the trailing zeros. We are not getting these zeros, even though they are present in the number, we are not getting count of them. Okay, so we are counting the trailing zeros in the number. Okay, now where it can be used. So acha, now tell me one thing. For this number, what is the reverse logic? What was the reverse logic giving you 21? Okay, now can you do two things? So if I ask you to print not 21, 2100, okay, so you can get 21 from the reverse logic that you can do. Can you count the number of trailing zeros? Can you do that? Can you get the number of trailing zeros? Now, can you add that many zeros to a number end? So for example, let's say you got 5 trailing zeros. Okay, there were 4 or 3 trailing zeros. Let's say you got 4 trailing zeros. Now, can you add 4 zeros to the end of any number? So let's say if you have a variable, let's say a is equals to 6, 7, 8. Now, can you add 4 zeros to it? So you just need to multiply it 4 times. A is equals to a into 10. And this is something you have to do 4 times. How do you do something 4 times, 5 times, or n times? You do it using loops. Not string. I'm not talking about string. Don't go to string. Okay, I'm talking about numbers. All these things can be done using numbers. Don't go to strings. That's very string has a lot of problems. Okay, for now, just think it like string has a lot of problems. Okay. Achha, let's say I have to add 4 trailing zeros or 3 trailing. You got the count of trailing zeros. Okay, so you can run a simple loop. I want to add, let's say, 3 trailing zeros. So I can simply do this, right? Don't go to strings. When I'll explain you about strings now, you will say, okay, sir, numbers were so good. Strings are so bad. Okay. So see, this is like the logic how you can add 3 trailing zeros, right? If I ask you to do that, so that you can do. Okay. So yeah, if I just print it, sorry, I did not print it. Now tell me, now can you add trailing zeros to a number? Can you count the trailing zeros? Can you add trailing zeros to the reverse of a number? If there is any other question where there is some problem because of trailing zeros, can you add it to the result? Can you get the result by adding trailing zeros to the number? Can you do that? Yes. Now in the number rotation question, okay, chalo, I don't even remember whether there was trailing zeros or not. So let's say if there are trailing zeros, can you add it in it? We'll learn about math module in this, but right now use loops. Okay, I'll explain you about math tomorrow, day after tomorrow. I'll cover that. Okay, so math is a small part. For now, use loops. Okay, I'll explain math. That is not a module that is there in this module. Okay, okay. Now, in the case of just one last thing, okay. So let's say there are 2 numbers. This is a number and this is a number. So till now you are adding 1 digit to the end of this. Okay, let's say you want to add one more number to the end of it. You want to add, this is 657 and you want to add 34 to the end of it. What do you need to do? Can you tell me step by step of it? What is the steps? Starting zeros, leading zeros is not there. So leading zeros is not there, going to be there in any input. Okay. No strings. I'm telling you, no strings. Tell me in terms of numbers. Numbers without string, nahi. No string. Okay. So one thing you can do is you can find out the length of second number, count the number of digits in second number. Okay. Write the steps. Count digits in second numbers. Can you do it? Okay, string has a lot of problems. Don't use string concatenation. Okay, when I will explain you time and space complexity, you will understand the problem. Why I am telling you not to use it. Interviewer will not allow you to use it. Trust me, nahi allow karega interviewer. He is going to tell you do it using numbers. You are not allowed to use strings. Okay, so you need to think it in terms of numbers, and there is a way to do it. Okay, so if you want to add this number to the end of this, so first thing is you can count the number of digits in second number. Okay, then multiply 10 to count times whatever count you got, right? in first number. Can you do this? So what this will make the first number? So let's say the count of second digits is 2. So multiply 10 2 times. So what is 10 2 times? It is going to make this number 56700. Count of digits is going to give you 2. So if you multiply 10 2 times in this, you are going to get this number. And then finally, what is the third step? Add the second number. So it is 56734. Okay, understood? Okay, so I told you how to count digits. You can do that. How you can multiply digits, how you can multiply numbers multiple times to a number, that I told you. Using loops you can do it in this way. And finally, how you can add that's like a normal addition. That's not a different thing. Okay, understood? Now try all the questions, all the digit related question, and tell me whether you are able to do it or not. There is only one question that was left. Check whether a number is prime or not. Can you do this? Now I'll start tomorrow's discussion with this. Okay, there is a lot of things to learn on this. Okay, so I'll start with this. This is a very good question. Even if you have done it, there is like a lot of things to learn, right? So even if you have done some questions, I generally bring something that you might not be knowing. Okay. Okay. Understood? Yes, no. Okay, now try all the questions related to numbers. Rotation, अब भी doubt है rotations में. So let me read that question. चलो rotation पढ़ी देते बता देते कि what you need to do. Okay, so let's see the rotation question. So this is the assignment that you need to complete today. No array required. You can do it using normal numbers manipulation. Do it using numbers, no arrays. Okay. Like what does rotation means? So rotation means that you have a number and you are given a k, and you have to move that k digits to n times. Okay. Acha. Chalo, if you, I don't know whether you observed this or not. So for example, okay, left or right rotation, leave that. Okay, left or right rotation is what I would say. Take a left or right rotation, that's not going to be so you can easily figure out whether you have to do a left rotation or a right rotation, depending on. Let me explain one of them, and the other one you can figure out. Okay, so let's say this is the number. Okay, so 1 2 5 6, and you have to do a left rotation. This is left rotation. Yes. So you take out the number from the right hand and you put it into the left side. Okay, so if it is 1, you take one number. What if it is like 2 or 3? Let's say, let me take a large number. Let's say 7 4. This is a number and I give you 3. So what is the final result going to look like? Is it going to look like this? If you rotate it 3 times, check it whether you are going to get this or not. So first step, let me do it 3 steps. So you are going to 4 1 2 5 6 7. Second step, 7 4 1 2 5 6. Third step, 6 7 4 1 2 5. Yes, same result that we got. Okay, so even if you do it in 3 steps, you are going to get this result. Now, how did I get it in a single step so quickly? See, if the number is 3, you can simply take last 3 digits and put it at the start. Okay, so it's a sir, like the k is not actually the size of the number. It is actually can be very large. K can be even 10 or 20, right? It is not restricted to the number of digits. If it has given k as 10, then how can I take 10 digits from the end and put it at the start? Number is having 6 digits. Valid question, right? Now, actually, you can do it percentage the number of digits. The k percentage the number of digits. What many digits you have? 6. So this will give you 4. Okay, so you have to actually, so the result of what 10 is going to be, you have to take 4 digits from the end. So 7 4 and put it at the start. Okay, so you can just take modulo to just reduce this k to the number of digits that you want to pick from it. Okay, you can do 10 rotations. I'm sure you are going to get this at this. Now there are 2 questions. Okay, let's say you figured this out. Ki percentage count of digits karna hai. This was first step. Okay, figure out ki percentage count of digits karna hai. Okay. Second step. Okay. Negative numbers ke liye you can additionally handle that. That is like percentage plus number of digits. That also works. Okay, or you can do it separately as well, right rotation. Now Next question, you have to break this number into two parts. Okay, so let's say you got this as 10, you got this number is two numbers. So yeah, how can I put it into start? So firstly, you cannot put it into start directly. You have to break this number into two parts. So you have to get this number separately and you have to get this number separately. Achha. So you got this as 4. Can you get the last 4 digits of a number? Last 4 digits of a number, you are going to get this as this. Can you again reverse it? You will get this. Okay, last 4 digits. Can you get the first 2 digits? How can you get the first 2 digits? 4 कैसे आया? Percentage 6. Percentage 6 is like the percentage, the count of digits. You have to take k percentage count of digits. Okay. So this is going to give you how many digits you have to remove from the end. Okay. You can do number of rotations, but actually the first 6 rotation is going to make the number same. देखो 6 बार rotate कर लो number को, it is after 6 rotation the number is again going to become this. Yes or no? If you have to do 10 rotations, after 6 rotation number is again going to become this. So the last 4 rotations, whatever will be the result, that is your final result, right? So instead of doing 10 rotations, I just told ki just let's do the last 4 rotations, because first 6 rotation is not going to do anything to the number, right? So even if it is like, let's say 20 or something, the first 18 rotation is, so if the k is 18 and the number is 6, so let's say k is 20. Okay. So, and the number is 6. So the first 18 rotations are going to make the number again back to same number. And the last 2 rotations are only going to affect the final result. Okay. Otherwise, the final result is same. Understood this part first? The percentage Q kara. How did we get this value, the number of rotations that you actually have to perform from K? So you're given a K and then you have to figure out what is the number. What if no more than 10 digits? So like it doesn't matter, right? If you do percentage, you will get the number of rotations, right? Okay. Okay. First you tell me got this. There are a lot of cases here. See, try to think of one problem at a time. So first problem solved. Second problem is how can we break this number into 2 parts? I gave you idea, right? How can you break this number into 2 parts? Okay. Now once you break this number into 2 parts, okay, so this part you can get last 4 digits, concatenate it, reverse it, again reverse it, you'll get the number. And then, or you can find out the first 2 digits by dividing it by 10 to the power whatever you want. 10 to the power 4, if you divide this number by 10 to the power 4, you'll get the first 2 digits. Okay, so you can take this out separately as well by skipping the first 4 and you can take this out. Okay, there can be multiple logic that you can write to break this. So let me assume that you figured out how you can break this into 2 numbers. If you broke this into 2 numbers, can you join them? I just gave you the logic of how you can join them. I just wrote the 3-step process, right? This is the 3-step process, how you can join 2 numbers. Okay. Now the last question is, sir, what if leading zeros, trailing zeros are gaya? What if we'll do that situation? So what if the number is like this, right? So let me just validate. So this is like 1, 2, 3, 0, 0, and let's say I have to rotate it by 2. So let's check the expected output first. So expected output is 1, 2, 3, right? It is not telling you to print those leading zeros. Okay? So the leading zeros, it will never expect you to print any leading zeros. It will always expect you to print only trailing zeros. Okay? So you can check the expected output if you have doubt for any particular input that is not here. So you can first check the expected output. So see, it is not asking you to print the leading zeros. Right? So if there are trailing zeros and we are rotating it by 2, then it is not asking. But if we are rotating it by 3, then it is going to be 300, 1, 2. That is fine. Right? This is fine. But if you are rotating it by 2, it will result in 2 leading zeros and you don't have to print them actually. So you don't have to do anything for the leading zeros. But even I told you how you can get the like trailing zeros, but if you have to count those, that logic also I gave you. Okay. Understood? Now try this question. I gave you everything that you need to solve this one. Just handle that right and left rotation. You should be able to find a solution, at least one. Okay. Understood? No, 0, 0, 1, 2, 3. So you don't have to print 0, 0, 1, 2, 3. You have to print 1, 2, 3 Anurag. Okay. So you can check the expected output. It is telling 1, 2, 3. If you have to print, let's say somewhere 0, 0, 1, 2, 3. So you can use print. System.out.print. You can count the number of leading zeros, print the zeros, and then print the number. ठीक है, use system.out.print, so you won't change the line, it will print it as a single number in the output screen. But there is no ways you can store a like leading zero in variable. That is not possible. Okay, so variable doesn't store leading zeros because that has something different meaning. Okay, clear? How to break the number into two parts? I gave you the logic. Think. Okay, now I'll say think or was the last 15 minutes again. Okay, try it out. There should be some question that you need to figure out. So you have to do the reverse, but up to certain digits, right? Not the entire number. Okay, clear? Understood? So tomorrow I'll see you at 11. Before that, try to solve these questions so that you have doubts, right? That we'll solve in class. We'll solve this rotation, number rotation anyways, because I know that if you will at least face doubts on this. So I'll solve it. Apart from this, what else question is there? That is that else. Okay, I'm sharing the link. Please put it in your WhatsApp groups, right? So the other students also get it. I'll check why this community is not working. Let me just share the link in chat. Okay, got it. Soft skill sessions, I guess it would be in evening. Just confirm with your batch manager because I gave already the slots from 11 to 2. So 11 to 2 is my session. I don't think it will, that will be there anywhere. And I don't think it will be there in the morning. Might be at 4 or 5 or something. Yeah, so it's 4. Okay, so that's fine. So you have the entire evening again for tomorrow. Okay, so that's the only Saturday you will get free. Otherwise, from the next Saturdays, you have contest that you have to appear. 11 a.m. 11 a.m. in the morning, right? So tomorrow's session is in the morning, 11 a.m. Okay, do join in the morning. Okay, thank you everyone. So okay, I wish you learned something new on loops. You already knew, but I guess you saw something different ways of loops, right? Something new operators, and learned a lot of new things today, right? Should I start practicing aptitude module CS theory? No, no need, right? Right now, just focus on DSA, right? Let's make your DSA strong. Okay, all other things, right? I can guarantee all the other things is super easy. I can teach you operating systems in 2 days, and I can make you interview ready on operating system. You can like literally sign those interviews. I can teach you OOPS in 5 days, and you can be very good. You can answer all the questions related to OOPS. But I can't teach you DSA in 5 days. That will take 3 months. Okay, so for now, focus on DSA. OOPS, theory parts, anything networking, operating system, all those things leave aside. That you will learn in very easy way. That's very easy, too easy to learn. Right? Very less practical things, lot of theories, so easily remember. Okay, so thank you everyone. See you all tomorrow. Good night. Bye bye. Take care. Do solve all your assignments. Good night.